Hello and welcome to Unity3d mobile game development course. In this course you will learn and build Android and iOS GTA Vice City game clone. You will learn and build many advanced features like camera sensitivity, game difficulty level, and a beautiful interactive UI for the mobile phones. So let's start a new game. You will learn how to add interactive user interface for the mobile screen for the Android and iOS. You see the mini map where you can mark location for yourself where you want to go. Other than this, you see the zoom in, zoom out, the mini map, the home location of Lance, that is our player character. The first mission you can see at the top, it is written that you will find Ken at the hotel. So our player character will go to the hotel. As you can see, he reached the hotel, and now the first mission he will get from here. So you will learn all these advanced features in this course, and also you will learn how to add cutscenes to your game. For example, now our player character is talking with Ken, so the story cutscenes you can see it is going on, that is both are talking with each other, just like you guys see in GTA Vice City. So the same thing is going on here with more advanced features specifically for the mobile using Unity game engine. So you will learn how to add cutscenes to a mobile game using Unity game engine. So now the new mission is assigned to our player character, where he has to go and find the weapons store, that is the weapon shop. So he will go and find that store. So for example, as you can see on the map, the weapon, that is the pistol symbol, is showing on the mini map in the game. You can see that. Upon reaching the weapon store, as you can see, it's reached on the map. Now our player character will go inside and purchase some weapons. So let's go inside. So you see that our player character has $200, and each weapon to purchase it has its own price. So for example, if you purchase this, then 50 will be deducted. As you can see, it is 150. Now purchase this, 70 deducted, so it becomes 80. The player has now 80, and now if the player purchase this one, 45, so 45 is deducted. So player has now $35 left, and he purchased these 3 weapons. Now this mission is also completed. Now the third mission is to go and find the BJ Smith. So on the mini map you can see the B sign. So our player character will now go and meet BJ. Okay, so our player character has to find BJ, and you can see that the player can change weapons. If you click on the right top corner on the weapons, then you can see that it is changing the weapon, so you can pick any weapon you want from there. So as I told you, you will learn how to implement the mission-based games for the mobile phones using Unity game engine. So for example, this current mission is to follow the B sign on the mini map, which simply means we have to find the BJ. BJ is basically the person. Upon reaching at the B, you will see that the cutscene will start. That is our player character find BJ, as you can see. So now our player character will take revenge from this BJ enemy character. So now when our player character kill BJ, who is basically the person who cheated our player character Lance. So now the next mission is our player will go and find Lance, and our player character has to kill Lance, and you can see the mission title at the top of the screen, that is Kill Lance. You will learn and implement advanced car controllers. So our player character can drive any car the player character wants. You will learn how to add drifting to the cars, and also you will learn and build AI cars into the game. You see in the map there are also AI cars running on the roads, that is driving on the roads. So you will learn advanced car controller for the player and also the AI car controller for the common people in the game. So now let's complete the last mission, which is to find and kill Lance. So our player character reached at the Lance location, which is represented on the map by the symbol D. As you can see, our player character take fight with the enemies, with the security guards of Lance. So our player character find Lance and also the main enemy of the game, which is the D character, the D enemy character. So this mission is completed, which says now all missions completed. So Lance is now the king of this game as he killed all the enemies and completed all missions. You will also learn and build the wanted level system. For example, if our player character break the law, then the police will follow him and send him to jail. For example, now you can see one star is highlighted, which means that wanted level is turned on for our player character. So you will learn all these advanced features in this course specifically for the Android and iOS using Unity game engine. So yeah, that's it for this video and see you guys in the course. Bye for now.
Hello guys and welcome back. So now from this video onwards we will start working on our new project. For starting it, first of all open up Unity Hub and in the projects menu click on this new project button, and right here in the all templates you will find this 3D mobile, so just click on it, and if you didn't download this template then it will show a button right here. Just simply download it. It will take a few seconds. Okay, after that let's name our project. So I'm gonna name this as GTA Vice City clone, okay, or whatever you want to name it, and then I will select the location. So the location will be this Unity project R, so I will select this folder, Then right here in the Unity Cloud organization, select your own account. My name in this option is Alisher as publisher, okay? And I will remove this connect to Unity Cloud. Then let's click on create button, and now in a few minutes our project will be ready and up running. So let's wait for it. So as you can see, our project is created and up running. Now in the next video we will add our environment and set up our whole environment. Okay, so see you guys in the next one. Hello guys and welcome back. So now in this video we will set up our whole environment. Okay, so for the environment you will be needing this file, okay, which is this environment files. Download this zip file, and when you extract it in here you will find these three files. Okay, so let's start from this first one, which is modern city pack. Let's extract this here as well. It will give you this Unity package. Double click on it, and when you do that it will open up this window. Just simply click on import, and if it shows this window just simply click on this second option, yes, just for these files. After that just simply clear the console, and now in the MCP folder click on the demo folder and then scene, and in here open up this MCP underscore day. Okay, so as you can see this is our environment. We will be expanding this environment. We will be adding roads on this side and also on that side as well, and we will be adding walls around the city, okay, so that the player don't go to any other location other than this map. Okay, and as you can see from some of the buildings the ground is missing, so we're gonna fix this all. Okay, first of all go ahead and extract this town constructor pack, because in this town constructor pack we have the walls prefabs. Okay, we need that walls in this environment. This is the package. Click on import. Okay, now if you click on this town constructor pack, click on this modular parts, and in here in the on-road decoration folder you will find these walls, as you can see. Okay, so we will be using just this, and if you want you can use the other prefabs of this package as well. Okay, now it will take a lot of time to fix this whole city. Okay, add walls and then set up the roads and add the ground. So what we will be doing is I will provide you the environment prefab. Okay, but before adding the environment prefab, make sure that you add these two package first. Okay, now let me simply delete all of these things from this. Okay, because we will be adding the environment again. And also in the assets, let's go ahead and create a folder. Let's name this as game assets. Okay, and in the game assets drag and drop this MCP and then the town constructor folder as well. Okay, so now they both are in here, and we will be adding the other assets in this folder as well. After this just simply minimize this, and this is the prefab which I'm talking about, so let's drag and drop this in here. Okay, so now what I will do, I will simply drag and drop this is in this MCP underscore day scene, and as you can see it is. Let me turn off the gizmos so that we can see this whole environment. Here it is. Let me click on reset so that the whole thing is reset. Okay, now if we zoom in, as you can see this will be our whole city. Okay, and right here I have created this area, so if you want you can add some other city in this area. Okay, but I will leave this as it is. We will be just focusing on this side of the game. Okay, if you scroll right there we have the gun shop right here. Okay, so if we move here and scroll down, this is the gun shop. Okay, now if you notice, the material right here is a little bit messed up. So what we're gonna do, we will click on this and click on this select material. So this is the material. We will change its styling. Okay, let's actually change it from here. Let's make this 150 and 150. So now as you can see, it looks good. Okay, so you can change this to whatever value you want. Let's leave this on 160. Okay, everywhere it looks good. Alright, so this will be our whole environment. Okay, and right here we will be adding the player house in this location, but that will be in the future videos. Okay, so now as you can see, our whole environment is set up, and if I show you the walls, they are added as well. Okay, and as I told you, is that first of all add this two packages, and then after that import the environment prefab. Okay, if you don't follow as I said, then there might be an issue with your walls. Okay, since the walls materials and prefab is in the town constructor pack. Okay, so everything is set up. Now the next thing which we will be doing is adding the player. Okay, but let's just do that in the next video. Right here, let's click on prefab and then click on unpack completely. Okay, and also let's select this scene. So select it, and then let's drag and drop this in the scenes folder. Okay, so this will be our mcp_day scene, and then let's rename this one to main menu. Okay, because we will also be adding our main menu, but in the future videos. Okay, so this is the whole environment. If you want, you can add more buildings right here, and right here you can add some gate or some entrance to that city. Okay, but I will leave this as it is. And also for the background you can add more buildings. Okay, as you can see right here, there are few buildings, but you can add more buildings around in this whole environment. All right, so with this done, let's end this video right here. Hello guys, and welcome back. So now in this video we will be adding our player. Okay, so for the player, as you know that the player character is required animations and also the player rifles and everything. Okay, so let's go ahead and add our player. For the player, go ahead and download this third person character, and if you extract this here, in here you will find this TPC folder. Let's drag and drop this inside our game assets. Okay, let's click on the game assets, and in here click on this TPC. In here you will find the AKM source. Okay, and this is the AKM prefab. Then we have the M16 assault rifle, and we have the animations. Okay, for the character, as you can see, they are humanoid, and the Tommy Vercetti uh, avatar is already selected. Okay, and if you click on pistol, you will find the pistol prefab, and then in here you can find the pistol animations. Okay, these all animations are from miximo.com website. Okay, and if you check this out, this is the other animation for the character. Okay, and in the Tommy Vercetti folder you will find the actual character. Okay, right here, as you can see. So Let's first of all give credit to the owner of these assets. Okay, these animations are from, as I told you, miximo.com, and this Tommy Versetti character is from Sketchfab, but I don't know if it was this character or this one or this one. I forgot, but it was one of this character, okay, which I have used in it. So shout out to all of these talented developers, okay. And also this AKM weapon is also from Sketchfab. So right here, if you search for AKM, click on downloadable. In here, as you can see, these are all of the AKM weapons, okay. So I forgot which one I have used, okay. I bookmarked that creator, but I don't know why it is not in there anymore, okay. But it was from Sketchfab as well, and all the other rifles as well. And also, if you want, you can use some other AKM prefab from here as well, okay. Now back right here, we now need to add our character. So if I click on Tommy Versetti, as you can see, this is the character, but we will not be using this character because this character doesn't have any rig, okay. If I show you, if you click on this animation, as you can see right here, the character is running, the Tommy Versetti character, but if you drag and drop this, as you can see, it is staying still, okay. So as I told you, I've downloaded these animations from the miximo.com website. So from the miximo.com, I have added a rig to this character. So in the mail locomotion pick, you will find this Tommy Versetti character, okay. You can move him to the ground like this, okay. And then for the material, just open up Tommy Versetti folder, click on material and drag and drop this material on there, okay. So as you can see, here is our Tommy Versetti character, okay. Here it is, as you can see. Now once we have the character, now if we check the animations, okay, drag and drop the character in there, as you can see, this is the player right there, working perfectly fine. And if you want to use some other character, then just simply upload this Tommy Versetti character to the miximo.com website, and then you can select different animations, and then make sure that you download each of the animation with your character, okay. Just as I did with the mail locomotion pick, I have downloaded the character so that the rig is added to this. I will even show you how you can do that. Just open up the miximo.com website, okay, log in using your Gmail or however you want to log in, and then click on upload character, and then in here just simply drag and drop your Tommy Versetti character like this, okay. Now as you can see, this is the character. Click next, add your chin, then this right here, okay, and then the elbows right here, then the knees, and then this right here, okay. Click next. Now as you can see, it is auto rigging the character, okay. Now as you can see, the character is rigged. Here is our Tommy Versetti character. Click next and next again. And now on this character you can use whatever animation you want, as you can see, okay, like this. Then you can download the animation for FBX for Unity and with skin, okay. Just simply click on download and it will be downloaded, and then you can open up that animation like this, and in there you will have your character, and then you can drag and drop that character like this, and then add the material from this Tommy Versetti like this, okay. So now as you can see, the material is added and we have the character right here. And also in the mail locomotion back, we have the player animator already set up, okay? But I will not be giving you this controller because we will be creating this controller from the start, or else you guys will get confused, okay? So let me delete it for now, okay? And also you guys will not have this controller as well. So with our character added, let's end this video right here. Hello guys and welcome back. So now from this video onwards we will work on our player controller. Okay, so as you know that this game is for the mobile devices, but also we will make this game playable for the PC players as well. Okay, so in order to make this game work on PCs we have to add the PC controls. Okay, for that we will be using the new input system in Unity. So if we click on Windows, then package manager, right here change this from in project to Unity registry, and let's search for new, or let's just search for input system. Okay, here it is. So just simply install it and it will show this warning, so just simply click yes. And when you do that, it will restart our Unity project, okay, as you can see. Okay, now after this, in the assets folder, let's go ahead and create a new folder by the name of scripts. Then let's go inside the scripts folder. In here, create another folder by the name of player controls. Okay, then in the player controls, we will create a C# script by the name of input manager. And also what we're gonna do is we're gonna create a input action. Okay, I think you guys can't see this option because it is cropped right here at the end due to my video editor. So what I'm gonna do, I'm gonna move this project window outside and let's move it at the top right here. And now inside the player controls folder, if I click on create, and now as you can see at the end right here, input action. Okay, so create an input action. Let's name this as player controls. Okay, now let's move this project down below again. And when you select this player controls right here, it will show this generate C# class. So click that and then click apply, so that it will create a player controls script as well. Okay, and the reason we create this script is because we want to access all of the input actions inside our project. Okay, so now let's create our action map and let's name this as player movement, since this will hold all of our movement keys. Okay, so player movement. In here we have this new action, so let's name this as movement. Okay, make this a pass through and then vector2. And now in here, as you can see, we have no binding, so I will delete that. And then let's click on this and create the second one, add up, down, left, right composite. Okay, and when you add that, let's name this as WASD. This will be vector 2D vector, and right here we're gonna change this to analog. Then for the up, we will select the keyboard W key. So right here, if we select this path and type W, okay, I don't know why it didn't show this input field. Okay, but if we type W, as you can see, it shows W keyboard, so select that. Okay, press enter. Now for the down, we're gonna select the S key. So if I type S, as you can see right here, S keyboard, select that. For the left it is A key, so A keyboard. And for the right, you can go inside the keyboard as well like this, press enter, then type D in here and select D keyboard. Okay, now as you know that we will be adding the inputs for the controllers as well. So if the player wants to play the game using a controller, then we need to add inputs for that as well. Okay, so after this WASD, let's click on movement and add another up, down, left, right composite, and now let's name this as left stick. Okay, as you know that on most of the gaming controllers we move using the left stick. Okay, so now for the up, we're gonna select the left stick. So let me type left stick and then slash up. Okay, and make sure that you select this gamepad. Okay, not anything else. After this, for the down, we're gonna select, let me go back. Okay, and let's type left stick down gamepad. Then for the left, we're gonna say left sticks slash left gamepad, and for the right, we're gonna search for left stick slash right gamepad. Okay, so now our inputs are ready. Okay, now we need to create actually we have the input manager script. So now what we're gonna do, we're gonna read these inputs, okay, whenever we press these keys. So you can either click on autosave, or if you click on this close icon, it will give you this window. So make sure that you click on this save, okay, so that all of the inputs get saved which we created. Now let's double click on the input manager script, and also let's open up the player control script as well. So as you can see, we have the player movement right here, and in the player movement we have this binding for WASD keys. So as you can see, up, down, left, right. Then we have another binding for the left stick. So up, down, left, right. Okay. So now we're gonna read these inputs. So first of all, we will say player controls, then name this as player controls as well. After this, we're gonna create a public vector2 by the name of movement input, and then we're gonna create the on enable method. Okay, let me remove that summary, and in here we're gonna say that if the player controls is null, then what we're gonna do, we're gonna set the player controls to the new player controls. Okay, and then we want to read the movement from the player controls. So we will say player controls dot player movement. Okay, this player movement is the name of the action map. Okay, player movement. Then we have an action in here which is by the name of movement, and then in the movement we have these movement inputs. Okay, so inside the player movement we have the movement actions. So we're gonna say if they are performed. Okay, then the movement input, we're gonna change value in that vector to, okay, so we're gonna say I dot read value, and that's it. Okay, after this we're gonna say player controls dot enable, and then we're gonna create on disable method, and in here we're gonna simply say player controls dot disable. That's it. Now if I click on prefab unpack completely, let's name this as player. Okay, and let's drag and drop the input manager script at the top right there, and let's start the game. So as you can see, there is no camera rendering, so that's why it is showing this. But if we press the W key, as you can see, Y changed to 1. If we press the S key, Y changed to -1. If we press the A key, it is now the X is -1, and if we press the T key, the X is 1. And also, let me clear that out. Okay. So my joystick is connected. So now if I move the left stick of my joystick, or you can say controller, upwards, as you can see, it is 1. And if I rotate it downwards, as you can see, it is now the X is changed to -1, and now the Y is changed, and also as you can see, X -1, X 1, Y 1, Y -1. And if I rotate it in 360, as you can see, the values get changed. Okay, so it means that the inputs are being read properly fine, and with our inputs added, let's end this video right here. Hello guys, and welcome back. So as you know that in the previous video we created our input manager script in which we read the movement inputs. Okay, now in this video we will add some basic movement and also basic rotation. So first of all, right here, let's go ahead and create a new script by the name of player movement. Okay, in this script we will handle the player movement as suggested by the script name player movement, or you can say player locomotion if you want. Alright, let's click on player, drag and drop this script at the top. Let's open this up. Right, first of all, on the input manager, what we want to do, we want to read the vertical and horizontal input separately, okay? Because right now they are both inside this movement input. Okay, so we want to separate them for our movement. So first of all, let's start from the vertical. So we will first of all take the vertical input in this float, and then the horizontal input in this float. Okay, then right here, let's create a method by the name of handle movement input. Let's make this a public void. In here we're gonna say vertical input equals to movement input dot y. Okay, and then horizontal input equals to movement input dot x. Okay, once we have these two, now let's click on our player movement, and in here let's remove both of the method, and at the top we're gonna make a reference to our input manager. Okay, let's name this as input manager as well, but the I will be small, and then after that we're gonna create a vector 3 by the name of move direction. Okay, and then we're gonna create a transform which will be for our camera object. So we're gonna name this as cam object, and then we will add a rigid body to our player, but for now we didn't add that, but we will anyways create a reference right here for the player rigid body. Okay, so let's name this as player rigid body. Right at the top right here, let's add a header by the name of script reference, and then right down below we're gonna create another header which will be by the name of movement. Okay, and right down below we're gonna create a public float by the name of movement speed, and by default let's set this to 5. After this we're gonna create a wake method, and in here we're gonna now set a reference for our input manager. So we're gonna say get component input manager. Okay, and the reason we do it like this is because both of the script input manager and player movement is on the same player game object. Okay, and for the rigid body we're gonna do the same, so it will be equals to get component rigid body. Okay, now once that is set up, now let's create a method for handling the movement. Okay, so we're gonna say handle movement, and in this we're gonna set the move direction vector 3 to cam object dot forward, multiply that by the input manager dot vertical input. Okay, and after this we're gonna say move direction equals to move direction plus camera object dot right. Okay, and let's multiply that by the input manager dot horizontal input. Okay, so this is our forward, backward, left, right inputs, and now let's normalize this movement. So we're gonna set the move direction to dot normalize. Okay, and then the move direction dot y will be equals to 0, and after this we're gonna say move direction equals to move direction, let's multiply that by the movement speed. Okay, and then we're gonna say vector 3 movement velocity equals to the move direction, and then we're gonna say player rigid body dot velocity equals to the movement velocity. So now let me explain what we did right here in the handle movement. So basically this handle movement method is basically used for calculating and applying movement to the player. Okay, and in here right here this move direction calculates it actually calculates the move direction based on the input received from the input manager and camera orientation. Okay, and right here this move direction dot normalize what this do is it normalize the move direction to ensure constant speed regardless of direction. Okay, and right here this move direction dot y equals to 0, this actually sets the move direction dot y to 0 to prevent vertical movement, okay, so that the player doesn't go up in the sky. And right here we multiply the move direction by the movement speed to determine the final movement velocity. And right here we assign the move direction to the movement velocity and sets the player rigid body velocity to the movement velocity. Okay, so what this whole method will do is it will handle the player movement based on input and camera orientation, ensuring constant speed and direction. Okay, now once we have the movement, now we need to also add rotation. Let's just do the rotation in the next video. Okay, so let me end this video right here. Okay, so let's go ahead and add the rotation, and after that we will test our game. Okay, so for that, first of all, right here we need to create a float by the name of rotation speed, and that's gonna be equals to, let's just say 12. Okay, and after that let's create a method by the name of handle rotation, and in here let's create a vector 3 by the name of target direction. This is going to be equals to vector 3 dot 0. After this, the target direction will be equals to the camera object dot forward. Let's multiply that by the input manager dot vertical input. After this, target direction will be equals to target direction plus camera object dot right. Let's multiply that by the input manager dot horizontal input. Okay, then we're gonna normalize this, so we will say target direction dot normalize. Okay, these lines are just similar to what we did in the movement. Okay, and then let's set the target direction dot y to 0. Okay, after this we're gonna create a quaternion by the name of target rotation, and this is going to be equals to quaternion dot look rotation. Let's pass the target direction right here, and then we're gonna say quaternion player rotation equals to quaternion dot lerp, and let's pass transform dot rotation, and then the target rotation, then the rotation speed, and multiply that by time dot delta time. Okay, then the transform dot rotation will be equals to the player rotation. Now in this handle rotation method, what we did right here is we declare a vector3 variable by the name of target direction and initialize it to vector3.0. Then right here what we did is, first of all, we calculates the target direction based on input received from the input manager and camera orientation. Then after that we multiplies the camera forward vector by the vertical input to get the forward direction. Okay, then we adds the camera right vector and multiplied by the horizontal input to get the staff direction. Okay, and then on the third line we normalize the target direction to ensure constant magnitude regardless of direction, and then we sets the target direction dot y to 0 to prevent tilting or rotating vertically. Okay, then right here what we are doing is we first of all calculates the target rotation quaternion using quaternion dot look rotation, which aligns the forward vector of the object with the specified target direction. Okay, and then on the second line we uses quaternion dot lerb or slurb to interpolate smoothly between the current rotation, which is transform dot rotation, and the target rotation. Okay, and then the interpolation factor is controlled by the rotation speed multiply by time dot delta time, where this time dot delta time ensures smooth rotation over time. Okay, and then right here we sets the player transform rotation to the calculated player rotation, effectively rotating the player towards the target rotation. Okay, so overall the handle rotation method calculates the target direction based on player input and camera orientation and calculates the target rotation using quaternions, smoothly interpolates the player rotation towards the target rotation, and applies the rotation to the player transform. This helps in aligning the player orientation with the desired movement direction, enhancing the player movement. Okay, now everything is set up, but as you know that these methods are private. Okay, so what we will be doing with this is we're gonna create a main method for this handle movement, handle rotation, and we will call that inside that main method. Okay, and then we will call that main method on another script which we will be creating in just few moments. Okay, first of all right here let's create a public void by the name of handle all movement, and in here let's call the handle movement method and then the handle rotation. Okay, and then let's get back to the input manager, and right here we have this method. So first of all right here let's say public void. Actually now let's make this private, so name this as handle all inputs. Okay, in here we will call this handle movement input method. Okay, and in the future we will call all of the other methods which will be for handling the jumping, sprinting, etc, etc. Okay, now once you do this on both of these script, now get back right here and let's create a C# script by the name of player manager. Now let's open the script. Let's remove all of that, and at the top let's make a reference to the input manager script first of all. After this, we're gonna make a reference to our player movement script, and then in the awake method what we will do is we will set up the references. So first of all, let's start from the input manager. It will be equals to get movement input manager and then the player movement. So this will be equals to player movement. Okay, then in the update method we're gonna call the input manager dot handle all inputs, and then in the fixed update we're gonna call the other one. Okay, so fixed update player movement dot handle all movement. All right, so once you do this, get back right here, and as you know that we don't have any camera in our environment, so we're gonna add a camera right here. Let's name this as main camera, and let's reset this main camera. Where is it? Right there. Okay, move it closer to the player so that we can see the player like this. Okay, so now we have the camera. Now on the player movement, as you can see, we have this camera object. So now the camera object will be equals to camera dot main dot transform. Okay, now get back right here, and right here we're gonna add the player manager script. So let's drag and drop that. Then let's add the rigid body to the player, and let's stop the rotation on XYZ because we will be handling rotation on our own. And then we will also add a capsule collider. So add a capsule collider. Let's click on scene view, double click on player. As you can see, there is our capsule collider. Let's move it to 1 on Y, make the radius 0.3 and the height, let's just say 2. Okay, so as you can see, there it is. Let's move it a little bit upwards like that. Okay, so let's make this 1.2. That's it. And guys, before playing the game, let's remove this line and make this camera object public. Okay, and when you do that, get back right here, drag and drop the camera object in there, and then let's go ahead and play the game. So now if we move our player forwards, as you can see, the player is moving forward. If we move it backward, the player moves backward, and to the left and right as well. And as you can see, the player can rotate as well. But for example, if you rotate the player to the left side, the player just switch back to the front, as you can see. So if you want, you can leave the player like this, but if you don't want it, then we will make this change in the next video. Okay, so with this done, let's end this video right here. Hello guys, and welcome back. So now in this video we will be adding animation to our player. Okay, so for animation, what we're gonna do is inside the game assets, let's go inside the tbc folder, and then right here let's go ahead and create a animator controller. Let's name this as player controller. Then click on player and drag and drop this controller inside the animator component, okay, like that. Then double click on it. Let's move these right here, okay, and on the side right here, let's create a float actually by the name of horizontal, and then another one by the name of vertical, okay. Then in here, let's create a new blend tree. Name this as movement. This is our blend tree. Make this as a 2D freeform directional, okay. Then let's add 3 motion fields for our idle, walk and run animation. We will also be adding the sprinting, but that will be in the future videos, okay. So now if you go inside mail locomotion pack, right here we have the idle. Make sure that the animations which you are using is set to loop time and loop pose, okay. And as I told you in the beginning of the course that I have made the rig of all of my animation and character as humanoid, and for the animation uh, source avatar I have added the Tommy character avatar, okay. So if you are using the same assets as mine, then there is no need to change anything, but if you are using some other assets, then make sure that your character and animation are humanoid, or if you want to leave it as generic, then you can do that as well, okay. Let's add idle. Then we need to add the walk, so here is walking, and then we need the run. So let me see, this is sprint, okay, here it is run, okay. So let's try and drop that in there, and now make this 0, and on the first idle animation we will leave this as 0. Then for the second one, which is walk, so if the value become 0.5, the player will be walking, and if it becomes 1, then the player will be running, okay. If we check it out, as you can see, the player is walking on 0.5, and if you make it 1, the player is running now, okay. And as you know that when we are moving to the left or right or in the back direction, then we want these animations to be played precisely in that direction as well. So for that, right here we will leave horizontal as it is, but right here we're gonna change this to vertical. So now we have the vertical as well, okay, and the horizontal as well now. So the player can move to left, right, and forward, backward as well. Now once our animator is set up, now let's close all of this and go inside scripts, and then in here we're gonna create one more script that will be by the name of animator manager. Now let's go ahead and click on player and drag and drop this animator manager right here. Then open this up, and in here we're gonna create a reference to the animator, and then we're gonna create two integer. The first one will be by the name of horizontal, and the second one will be vertical, okay. Then in the awake method, what we're gonna do is we're gonna set a reference to the animator. So animator equals to get component animator, Then horizontal will be equals to animator dot string to hash. We're gonna pass the horizontal right here, and then let's do the vertical. So animator dot string to hash, then we will pass vertical again. After this, we need to create a method by the name of update animator values. This will be needing a float as a parameter by the name of horizontal movement, and another one by the name of vertical movement. Okay, in here we're gonna say animator dot set float horizontal, and then let's pass the horizontal movement, and then we're gonna pass 0.1, then we're gonna say time dot delta time. Okay, after this we're gonna do it for the vertical as well. So vertical, then right here pass vertical movement, and that's it. Okay, now after this, as you know that we will be using joystick in our mobile phone, and also if any player that is playing this game on a controller, or you can say on a joystick, then as you know that while using the left stick of the joystick, the animator value will not be always set to 0 or 0.5 or 1 or 2. As you know that on joystick it can be different, like 0.5511, something like that. Okay, so in order to fix that issue, we will be using animation snapping. Okay, so right here at the top, create a float by the name of snapped horizontal, then snapped vertical. Okay, then right here let's create a region by the name of snapped horizontal, and let's end this region right here. Okay, now in here we're gonna say that if the horizontal movement is greater than 0 and horizontal movement is less than 0.55. Okay, then what this means, we're gonna just simply now set the snapped horizontal to 0.5. It means that the player is walking. Okay, as I told you, while using the joystick, the value can be 0.55 or 0.5122 or something like that. Okay, so if it is that, then we're gonna just simply set it to 0.5 and the player will be walking. Okay, and then we're gonna say else if the horizontal movement is greater than 0.55, then it means that the player is now in a running mood. So we're gonna set then the snapped horizontal to 1. After this, we're gonna say if the horizontal movement is less than 0 and horizontal movement is greater than minus 0.55. Okay, then in this case the snapped horizontal will be equals to minus 0.5. Okay, and after this we're gonna say that if the horizontal movement is less than minus 0.55, then the snapped horizontal will be equals to minus 1. Okay, or else it's gonna be 0. That's it. Okay, so this is for the horizontal. Now let's do the same thing for vertical as well. Okay, so we can copy this whole region, and actually let's give space right there and paste it. Now let's change this to vertical and change this as well now to vertical movement. Okay, so in here now change this to vertical movement, vertical, vertical, vertical right here as well, and change snapped horizontal to snapped vertical as well. That's it. And then in here now we're gonna pass snapped horizontal, and instead of vertical movement we're gonna pass snapped vertical. That's it. Now after this we need to call this method on our input manager. So right here at the top we're gonna say animator manager, name this as animator manager. Okay, and let's make a awake method. In here we're gonna say animator manager equals to get component animator manager. Now right here let's create a float by name of move amount. Okay, then in the handle movement input method what we're gonna do is we're gonna clamp this move amount. So move amount will be equals to mathf dot clamp, and we're gonna say mathf dot abs. Let's pass horizontal input plus mathf dot absolute, and then the vertical input. Okay, then let's call the method. So animator manager dot update animator values. For the first parameter we will pass 0, and for the third one, which is vertical, for that we will pass the move amount. Okay, for the vertical movement. That's it. Here make sure to add f at the end of the 0.1, and then get back to Unity. Let's start the game. And now as you can see, the player is playing the animation perfectly fine. Test this out on our joystick. As you can see, it is working perfectly fine on the joystick as well. Okay, but as you know that when we rotate the player just switch back to the front side again, as you can see. So we don't want that. Okay, we're gonna fix this now. For this we're gonna open up the player movement. Okay, and in the handle rotation After this, we're gonna say if the target direction is equals to vector 3 dot 0, then target direction will be equals to transform dot forward. That's it. Now if we test it out again, as you can see, the player is now not looking forward again. When we rotate or move backwards, as you can see. Okay, so now we have the player movement, rotation, and we also play animation now. In the next video, we will work on our main camera so that the main camera follow our player. Okay. Okay, so in this video, we will now work on our camera. Okay. So first of all, right here, we need to set up the buttons for our camera movement and rotation. Click on this actions plus icon. It will create a new action. Let's name this as camera movement. Let's delete this binding. Let's click on this plus sign and add another binding, and in here what we're gonna do, we're gonna search for delta. Actually, we need to first of all delete this again. Click on camera movement and change this to pass through, and then this to vector 2. Okay, then after this, click on add binding, select this binding and search for delta mouse. Okay, so using our mouse, our camera will rotate around the player. Okay, and we also want to rotate the camera using our joystick, or you can say controller as well. And as you know that in most of the games, the camera rotate using the right stick. Okay, so let's add up, down, left, right composite. Let's name this as right stick. Okay, for the up, we're gonna select the right stick up. Okay, in here we're gonna select the right stick down, and make sure that you select this gamepad option. Okay, and for the left we're gonna select right stick slash left, and then for the right we're gonna select right stick slash right gamepad. Okay, that's it. If you click on cross sign, it will give this option, so click on save, and that's it. So now our controls are ready. Let's open up the input manager script, and now let's read these controls just as we did for the movement. Okay, in the same manner. So we're gonna create a public vector2 by the name of camera input. Then right down below, we're gonna copy this, paste it, and now we're gonna say camera. Actually, this will be player controls. Then in the player movement, we have the camera movement, and then in the camera movement we have the camera input. Okay, this is actually this vector to camera input. So we're gonna read the values and store that values in this vector to camera input. If we save the script and start our game, now if I move the mouse to the left side, as you can see, X is changing, and to the right side it is going in plus values and up and down as well. And if you check it using our joystick, as you can see, using our joystick it works as well, as you can see. Okay, -1 1 1, and then -1. Okay, so it works on the mouse and on the joystick. Once we are reading the camera inputs, now it's time to separate the vertical and horizontal. So I will simply copy that, and what I'm gonna do actually is cut this whole thing, move it right there, and then paste it again right here, and now change this to camera input X and then camera input Y. That's it. Now let's scroll down, and right here now we're gonna say camera input X equals to camera input dot X. Okay, and then camera input Y equals to camera input dot Y. Okay, now we can make this private and this vector 2 as well. That's it. Get back to the game again, and right here click on this main camera and right click on it actually, and click on this create empty parent. Okay, and when you create an empty parent in here, name this as camera manager, and then click on this main camera again and click on create empty parent again, and this time let's name this as camera pivot. That's it. Now in here let's create a C# script by the name of camera manager, and let's attach this script to our camera manager, and that's it. Okay, now in the next video we will make this camera follow our player. Okay, so now in this video we will make the camera follow the player. Okay, so go ahead and open up the camera manager script. Then let's remove these two methods, and at the top first of all we need a reference to our player game object transform. Okay, so we're gonna say public transform. Let's just name this as player target, or let's just name this as player transform. Okay, then we're gonna create a private vector 3 by the name of camera follow velocity. Okay, and this will be equals to vector 3 dot 0 by default. After this we're gonna create a float by the name of camera, or actually cam follow speed, and this will be 0.2, or let us say 0.5 or 0.1 actually by default. Okay, after this in the awake method the player transform will be equals to find object of type. We want to find that object which has the player manager script, and then dot transform. Okay, so it will search for the player manager in the components of each game object, and then to whatever game object this player manager script is attached, it will get that game object transform. Okay, then let's create a method by the name of follow target, and in here we're going to create a vector 3 by the name of target position. This will be equals to vector 3 dot smooth damp. First of all, let's pass the camera position, then the player position. So we're gonna say player transform dot position. Then we're gonna pass the camera follow velocity. So we're gonna say camera follow velocity, and then the camera follow speed. Okay, and then right down below we're gonna say transform dot position equals to the target position. That's it. Now right here add a update method, and inside the update method let's call this follow target method. Okay, now if we get back right here, as you can see, here is our camera manager. There is the player transform, the camera follow speed. If we play the game, as you can see, now the camera is following the player, but if you notice, the camera is in the player feeds. So now we're gonna set the camera pivot. Okay, we're gonna move the camera upwards and then a little bit down like this. Okay, we need to rotate the camera a little bit down like that. Okay, so I'm gonna leave this as 12, this will be 2, and this will be -3. Let's make this 3, or let's just 2.5, and then this will be 3.5. Okay, so in this way you can set up the camera. Okay, as you can see, the player is shaking a little bit if you notice, so we're gonna fix this as well. Okay, but before stopping the game, let's copy the component of the camera pivot, and when you stop the game, click on paste component values. That's it. Then click on player, and right here change the interpolate to interpolate. That's it. Now if you play the game again, okay, now as you can see, the player is running smoothly. Okay, and if you notice right here, the player feeds are just fine, but the player, if it moves to this other surface, as you can see, the player feeds then gets inside the ground. Okay, this is due to the colliders and also the surface. As you can see, the surface is a little bit down, so what we're gonna do is we can select it and move it a little bit up. Okay, let's make it 3.1. Okay, as you can see, here it is. Make it for 3.0708. Okay, 07. And also select the player now and move the player up like this, and we need to change the height of the capsule collider to 2.2. Okay, and let's move the collider down like that. Okay, now let's play the game again. Okay, and as you can see, it looks good now. Okay, let's make it 0.1. Okay, 0.1 is a good value for this. So leave it on 2.1. That's it. So now the camera can follow the player. Now in the next video, we're gonna add camera rotation. So see you guys in the next one. Hello guys and welcome back. So now in this video, we will be adding rotation to our camera, okay? So open up the camera manager script, and at the top we will make a reference to the input manager script. So input manager, let's name this as input manager. Then in the awake method, we're gonna say input manager equals to find object of type input manager. That's it. After this, we're gonna create some variables. So let's create a header by the name of camera movement and rotation. And in here, the first one will be a float by the name of camera look speed. And the look speed will be, let's just say 0.1. Okay, then the next one will be camera pivot speed. After this, we're gonna create a public float. Okay, and this will be by the name of look angle. Then the next one will be by the name of pivot angle. Then if we scroll down, right here we're gonna create a rotate camera method, and in this, first of all, we will set the look angle to look angle plus input manager dot camera input x, multiply that by the camera look speed. Okay, then the pivot angle will be equals to pivot angle plus, actually this time we're gonna use minus, so minus input manager dot camera input y, and multiply that by the camera pivot speed. Then we will create a vector 3 at the top right here by the name of rotation, and also we're going to create a quaternion by the name of target rotation. Okay, then right down below we're going to say rotation equals to vector 3 dot 0, then rotation dot y will be equals to look angle, and then we're gonna say target rotation equals to quaternion dot Euler, and let's pass the rotation to it, and then we're gonna say transform dot rotation equals to the target rotation. Okay, then rotation will be equals to vector 3 dot 0, and the rotation dot x will be equals to the pivot angle. Okay, and then the target rotation will be equals to quaternion dot Euler rotation, and then camera pivot. We didn't create this camera pivot, but we're gonna do it in a moment. So camera pivot dot local rotation equals to target rotation. Okay, now let's move to the top, and right here we are adding transforms. So for this camera pivot, we're gonna do it right here. Okay, now let me tell you what we are doing in the rotate camera method. So first of all, we declare a vector 3 a rotation and a quaternion variable by the name of target rotation. Okay, then right here we are calculating horizontal and vertical rotation. So we adjust the look angle based on horizontal camera input, which is this camera input x, and we multiply that by the camera look speed, and right here we adjust the pivot angle based on the vertical camera input. Okay, this camera input y, and we multiply that by the camera pivot speed. Simple as that. And what this do, this basically control the horizontal and vertical rotation of the camera. Okay, then right here we have the horizontal rotation. So what we did right here is, first of all, we reset the rotation vector to 0 and set the rotation dot y to look angle, controlling the horizontal rotation. Okay, and then we created this target rotation. So that target rotation quaternion is using quaternion dot Euler with the calculated rotation vector. Okay, this vector 3, and then we applies the target rotation to the transform dot rotation of the camera, rotating it horizontally. Okay, and then right here we are managing the vertical rotation of the camera. So just as we did for horizontal, we did it for vertical. We first of all reset the rotation vector to 0 and set the rotation x to the pivot angle. Then the target rotation quaternion is using quaternion dot Euler with the updated rotation vector. Okay, and then after that we applies the vertical rotation, which is this target rotation, to the local rotation of the camera pivot transform. So this is really simple. Okay, if you want you can add comments as well. For example, right here we are declaring the variable, so we will type variable declaration, and then right here we are calculating horizontal and vertical rotation. Then right here we are managing the horizontal rotation, and then right down below we are managing the vertical rotation. Okay, simple as that. So once you do this, now right here what we're gonna do is we're gonna change this to handle all camera movement. Whoops, we already have that curly brackets, so just remove that. So this will be our method, and in here we will call the follow target and then the rotate camera as well. And then if we get back to our player manager script, okay, then right here in the update we actually need to provide the camera manager script now. So we're gonna say camera manager. Let's name this as camera manager, and then camera manager will be equals to, let's copy this line from the camera manager script and paste it right here on the player manager. So find object of type camera manager. Okay, you can also drag and drop the camera manager script reference in there, make it public and drag and drop it. But if you don't want to do that, then you can type this line simply. Okay, and then in here we will say camera manager dot handle all camera movement. That's it. And just make sure that your handle all camera movement method is public. Now just simply save the script. Okay, we need to provide the camera pivot right there, so just simply drag and drop the camera pivot in there. That's it. Okay, let's now play the game. Okay, so now as you can see, we can rotate our camera up, down, okay, and to the left and right. But if you notice, we can rotate our camera all the way up and all the way down, like on 360, and we actually don't want that. Okay, we want some limitation to the camera angle. But now if you see, we can move the player in the direction of the camera, as you can see. Okay, and also the camera can rotate, follow the player, and the player can follow the camera as well, as you can see. Okay, so with this added, let's end this video right here. Hello guys and welcome back. So in this video we will fix this issue with our main camera. So if we move our camera in the upward direction, as you can see, the camera can rotate 360. Okay, we don't want this, so we will be restricting the camera angle. On the camera manager script right here, let's create a public float by the name of minimum pivot angle. This will be equals to -30. Then the next one will be maximum pivot angle, and this will be just 30. Okay, then if we scroll down right here, we will say pivot angle equals to mathf dot clamp. Let's pass the pivot angle, then the minimum pivot angle, and then the maximum pivot angle. Okay, and right here you can also add a comment restricting camera angles. Okay, now if we get back right here and on the camera manager script, we have this now. So let's start the game now and see if it works or not. Okay, so as you can see, the pivot angle is 30. You can see it right here. Okay, it doesn't go above 30, and if we move down, as you can see, it doesn't move down then -30. Okay, as you can see, and we will leave the other rotation like this because we want the player to rotate endlessly. Okay, so with this done, let's end this video right here, and in the next one we will be adding camera collision. Hello guys and welcome back. So in this video we will be adding sprinting to our player. Okay, first of all, let's go ahead and set a button for sprinting. So if I open up the player controls right here, let's create another action map. we're gonna name this as player actions, and inside this player actions we will create button for sprinting, jumping, firing, reload, scope, and interact as well. Okay, so let's name this as B. The action type of this will be button, and in here select its binding, and in here we're gonna select the button east of the gamepad, and also we're gonna add another binding, and this time this will be the shift key of the keyboard. Okay, so we're gonna use this button for that purpose. Actually, these two buttons, if you are using controller, then it will be button east, and if it is PC keyboard, then it will be shift key. Okay, let's save this. Now let's set up the animation for it. So we will add another motion field, and this time we're gonna select the sprint. Okay, here is the sprint animation, as you can see. So I'm gonna drag and drop that in there, change this to 0, and right here type 2. Okay, now if we play the animation, as you can see, the player is walking, now the player is running, and now the player is sprinting. Okay, once you add the animation, go ahead and open up your input manager, and on the input manager what we're gonna do now is we're gonna say public bool b input. Now let's read the b input from the input system. Okay, so it is inside the player controls, then the player actions this time. Okay, not player movement. So player actions, then the button name is B, and now if that button is performed, or you can say if that button is pressed, then B input will be equals to true. Okay, and if it is cancel, then it will be false. Actually it is cancelled, like that. Now after this, if we click on player movement, right here let's create a header, name this as movement values, and at the top make another header, name this one as movement flags, name this pool as is moving. Okay, and then another one will be is sprinting. Then in the movement values, what we will do is we're gonna create a float, sprinting speed equals to 13, let's just say, and also we need to add one more, which will be by the name of walking speed. Okay, let's just make the sprinting 7 instead of 13. That's it. Then after this, get back to the input manager, and right here at the top let's make a reference to our player movement script. Okay, name this as player movement, and right down below we're gonna say that player movement equals to cut component player movement. Okay, then after that, right here let's create a method for handling the sprinting, so you're gonna name this as handle sprinting input, and in here we're gonna say if the B input is pressed, and also if the move amount is greater than 0.5, then it means that the player is sprinting. So player movement, whoops, okay, player movement dot is sprinting will be then equals to true. Okay, and if this is not the case, then it will simply be false. That's it. Then we need to call this method in the handle all inputs method. Now you can go ahead and test the shift button and the joystick button out. It will read the values from it. But now we will not be testing that right now. We will now be actually playing the animation whenever we press the sprint button. Okay. So for that we have to open up the animator manager, and in this method update anim values, this will require another parameter by the name of is sprinting. Okay, and then right after this, what we're gonna do, we're gonna add another if condition, and in that we will say if the player is sprinting, then the horizontal snapped horizontal actually, this will be equals to horizontal movement, and snapped vertical will be equals to just 2. Okay, this is the 2 which we provided in our animator motion field. Okay, that's it. Now we need to get back to the input manager script. Now as you know that this update animator values now requires a pool, so for the pool we're gonna pass this player movement dot is sprinting. After this, if we check the player movement, okay, right here when the player is moving, the movement speed is applied, which is 5. Okay, so what we want now, as you know that the player has walking, running and sprinting animation. So for example, if the player right now is sprinting, if you hold down the shift button, you will notice the player will sprint. Okay, but the speed and the player speed and the animation speed will not be the same. Okay, the player will be sprinting but in slow speed, so we don't want that. We want to change the speeds according to the values right here provided. Okay, sprinting speed, movement speed, walking speed. Okay, so what we're gonna do, we will say that if the player is sprinting, then let's cut that from here, paste it in here. And if the player is sprinting, then we can apply sprinting speed to the move direction. Okay, else, now in here we're gonna say if input manager dot movement, actually move amount is greater than or equals to 0.5, then we want to apply the running speed. So move direction will be equals to move direction. Let's multiply that by the running speed. Let me check. Where is it? Okay, walking, and okay, change this from movement speed to running speed. okay, because we don't have any movement now. It is just sprinting, running, and walking. Okay, and when the player is running, we will set the is moving to true. Okay, and then in the else if, we're gonna say that if the input manager dot movement amount is greater than or equals to 0.5, then we're gonna copy and paste that right here, set this to false and set this to walking speed. That's it. Okay, let's click on input manager and right here just type I. Okay, instead of int. I don't know why I type int, it was I right here. And also on the player movement script, make the actually on the input manager, okay, right here make this move amount public, okay, because we are using this move amount right here. Okay, if we get back right here, it is showing errors on the player movement 51, 56. Okay, let's check it out. 51 right here. Okay, make this I small and right here as well. Okay, then if you get back to Unity and play the game, then if we hold down the shift key, as you can see the player is sprinting. Okay, as you can see, if we check it out on our controller, as you can see, I'm moving the joystick, and if I press the B key, okay, I have the Xbox controller, and on the Xbox the east button is B. Okay, as you can see the player is sprinting. And we can also rotate the camera as well, as you can see. And the player can walk towards that area using the joystick. Okay, so everything works perfectly fine, and with this done, let's end this video right here. Hello guys and welcome back. So in this video we will be adding falling and landing to our player, because right now if you move the player up in the air and then start the game, you will notice that the player is falling really slow, and also the player is able to walk in the air. Okay, so we don't want that. We want that when the player is in the air, we don't want the player to walk, we just want the player to stay still, and also we want to move the player quickly back to the ground. Okay, so first of all, open up the animation, the mail locomotion pack, and in here you will find the falling idle animation and the falling to landing. Okay, there are two landing animations, so you can use whatever you want, but I'm gonna use these first two since they match. Okay, so let's click on player, get back to the base layer. Okay, and what we will do right here is we have this base layer, so we will add our falling landing to another layer. Okay, we just gonna create a new layer. Okay, let's move these up right there. Then first of all add the falling animation, which is this one, so drag and drop it, and then the fall to landing, add this one as well. Let's rename the first one just to falling and rename this one to just landing. Okay, then also go ahead and create an empty state. Okay, move it right here and set this as a default state, and then from falling to landing make a transition, and then from landing make a transition to new state. Then click on parameters and right here create a pool by the name of is interacting. And guys, the reason we created this is interacting pool is because when the player will be falling, okay, then we don't want the player to move or run in the air, okay, so that's why we created this interacting. So if this is interacting is true, then the player will be able to jump, and if it is false, then in that case only the player will be able to walk, okay, because if the player is in the air, then this is interacting will be true and it will not allow the player to walk or run. Now after that, open up the animator manager script, and right down below this method, let's go ahead and create another method which will be by the name of play target anim. This will require a string and its name will be target anim, okay, and then it will require a bool which will be by the name of is interacting, okay. So now right here we will say animator dot set bool. Let's set the is interacting bool to the is interacting bool right here, which is this one, okay. So if we pass true to this, then the is interacting, which is in the animator, will be set to true, and if we pass false to this, then it will be false, okay. After this, we will say animator dot cross fade. Let's pass the target animation and then pass 0.2f. After this, click on player manager, and on the player manager, let's go ahead and create a bool by the name of is interacting. After this, right here, we're gonna create a late update method, and in this we're gonna say is interacting equals to animator dot get bool, and then we will get the is interacting bool from the animator, okay. So if that is true, then the is interacting bool on this script will be true, and if it is false, it will be false as well. Also make sure that you add a reference to the animator at the top right here, okay. So just type animator, name it as animator, and then right down below animator will be equals to find object of type animator. Actually it is not an object, it is a component, so we need to type get component animator, okay. After this, on the player movement script, let's go ahead and call the player manager script right here. So we're gonna say player manager, name this as player manager as well, and then right down below we're gonna say player manager equals to get component player manager. And the reason we created a reference to the player manager, because now on the player manager we have this is interacting bool. So if that is interacting bool is true, then we don't want the movement and the rotation of the player, okay. So we're gonna say player manager dot is interacting. If that is true, then just simply return from here and don't execute the handle movement and handle rotation. Now after this, if we get back to Unity, right here on this new state, we're gonna create a new script by the name of reset bool, create and add, And once it is created, let's double click on it and open it up. Right here at the top, let's create a public string by the name of is interacting bool, and create a bool by the name of is interacting status. Okay, then we're gonna uncomment this method which is on start enter. So in here, what we're gonna do is we're gonna just simply say animator dot set bool is interacting bool, and then pass the is interacting status. Okay, after this, get back to the player movement, and now let's add the falling and landing method. Okay, but before adding the method, we need to declare some variables for it. So first of all, create a header for it by the name of falling and landing. Then create a float by the name of in-air timer, and create another float by the name of leaping velocity. Then the next float will be falling velocity. Then the next one will be raycast height offset. Let's make it 0.5 f, and then we will be needing a reference to the ground layer mask, so let's name this as ground layer. Okay, this is all the variables which we need. Right here in the movement flags, create a bool by the name of is grounded. Okay, now if we scroll down to the bottom, let's go ahead and create the method. So let's name this as handle falling and landing. So let's first of all complete the method, and then I will explain what is happening in here. Okay, so first of all, we're gonna create a variable of type raycast hit by the name of hit, then a vector3 by the name of raycast origin, and this will be equals to transform dot position. Okay, then we're gonna create a vector3 by the name of target position, and then we're gonna say raycast origin dot y equals to raycast origin dot y plus raycast height offset. Okay, then the target position will be equals to transform dot position. After this, we will check that if the player is not grounded, and also in the future we will say if the player is not jumping. Okay, but for now we don't have any jumping, so we will leave the comment. And now if the player is not grounded, then we want to play the falling animation. Okay, so first of all, right here, check if the player is not interacting. Okay, so we will say player manager dot is interacting is not true. Okay, and if that is the case, then we want to play the falling animation. So now for that, as you know that we have created this play target animation method on the animator manager, to which we provide the animation name and then the is interacting bool. Okay, so we're gonna need this method right here on the player movement now. So at the top, we're gonna say animator manager. Let's name this as animator manager as well, but the A will be small. Then right down below, we're gonna say animator manager equals to get component animator manager. Okay, now in here we will say animator manager dot play target animation. For the animation name, we're gonna pass falling since this is the name of the animation, and for these interacting bool we're gonna pass true. And if you check the animation name right here, falling and landing. Okay, so make sure that you type the exact same name right here. Okay, so now when the player is falling, then we will set the in-air timer to in-air timer plus time dot delta time. Okay, after this we're gonna say player rigid body dot add force. Right here let's pass transform dot forward, multiply that by the leaping velocity. After this, player rigid body dot add force, let's say minus vector 3 dot up, multiply that by the falling velocity and multiply that by the in-air timer. Okay, now after this we need to play the landing animation whenever the player touches the ground. Okay, so for that what we're gonna do, we're gonna create a sphere around the player feet, and if that sphere touches the ground, then it means the player is on the ground and we will play the landing animation. Okay, so let's first of all create a sphere. So we're gonna say physics dot sphere cast. The area of the sphere will be raycast origin. The radius will be 0.2 f. You can make this as 0.3 or 5 or whatever you want the radius of the sphere to be. Okay, let's move it in the feeds. So we will say minus vector 3 dot up, and we will say out hit, whatever it hits we will store it in the hit variable, and for the layer we will pass the ground layer. Okay, and now we will add a if condition. So if we are creating this sphere, then we will check if the player is not grounded, and also if the player is not interacting. If that is the case, then we will play the animation. So we will say animator manager dot play target animation. The animation name is landing and set it to true. Right after this we will say vector 3. Let's pass the raycast hit point. No, actually we're gonna create a vector 3 by the name of raycast hit point, and this will be equals to the hit dot point. Okay, then we will say target position dot y will be equals to raycast hit point dot y, and in air timer will be equals to 0, and the is grounded will be equals to true. That's it. After this, we're gonna add else condition to this, and in which we're gonna just simply say is grounded equals to false. So just simply save the script, get back right here, and as you know that on the script we are calling the animation by their names now, so we don't have to add this transition now, okay, this transition line. So just simply delete it. That's it. Now let's click on player and add these values to right here. Okay, so in your timer it will be 0 because it will be updating when the player is falling. Okay, the leaping velocity will be, let's just say, 0.25 or 0.25. The falling velocity will be 60, and for the ground layer we need to provide the ground layer. So we get in here, as you can see, all of these things will be the ground. Okay, and if you notice, they are on the default layer. Okay, so if you click on the player right here, for the ground layer we're gonna provide default. Okay, and make sure that your player is on player layer. Okay, and that is all. Now before testing the game out, one thing we need to do is now to call this method right above the if condition. Okay, and then on the animator click on layer and make sure that your new layer weight is 1. Okay, because if it is not 1, then these animations will get ignored. Okay, and if you check the base layer, its weight is already by default 1, and also make sure that this weight is also 1. And let me make this transition back again. Okay, it works perfectly fine. Leave this as it is for now. And guys, before testing the game out, make sure that you click on this new state, and right here in the reset bool we forgot to add this is interacting bool. Okay, so make sure that you type this exact same name in there. Okay, and when you do that, then here is our player. As you can see, let's play the game, and you will notice that the player will move to the ground, as you can see, and this interacting bool is now false. Okay, let me also lock this cursor to the screen. Okay, for this open up the camera manager script, and right here on the awake at the top type these two lines: cursor dot lock state equals to cursor lock mode dot locked and cursor dot visible equals to false. That's it. Then get back to Unity back again. Okay, everything is set up. Make sure that you have this transition and you type is interacting in there. Let's play the game. Okay, as you can see, the player is falling and now the player is on the ground. Okay, if we check it right here, okay, as you can see, is interacting is false. Now if we click on scene view, here is the player. You will notice this is interacting gets set to true when the player is in the air. Okay, let's move the player to the air. As you can see, it is true and now it is false. Okay, let's move the player back again, and as you can see, the player lands perfectly fine. Okay, so now the player is also on the ground, as you can see. Okay, everything works perfectly fine. We have the falling and landing animation working perfectly, and in the next video what we're gonna do is we will add jumping to the player. Okay, so see you guys in the next one. Hello guys and welcome back. So now in this video we will be adding jumping to our player. Okay, so for that, first of all click on the animator, and right here we need to create two bools. The first one will be is jumping, and the second one will be is grounded. Then we need to add the animation. So in the main locomotion pack, let's search for jumping. Okay, right here we have this jump, so just drag and drop it in here. Okay, and if you play it, as you can see, this is the jumping animation. Okay, now make a transition from jumping to falling. Select that transition, remove the as exact time, and right here make the is grounded false. So when the is grounded is false, it means that the player is in the air, okay, not on the ground. So the player will just simply start falling like that, okay. And actually we need to trim this animation as well. So if we play the animation, as you can see, we just need this animation, okay, not the half of it. We don't need the half of it. We just want that when the player is in the air like that, that's it. Okay, somewhere right here on 33. Yes, 33 will be a good value for it. So now if we select it, as you can see, the player will be in the air then, falling. That's it. And after this transition, make a transition to the new state, and right here remove that. And this time when the is grounded is true, it means the player is on the ground. Then we will just simply start playing the locomotions animations. Okay, that's it. Then we need to set up a button for this. So in the scripts folder, open up the player controls folder and then open up the player controls. Let me try and drop it right here. Click on player actions, and now we're going to add another action. So click on the plus sign. Let's name this as jump. Okay, and in the binding, the first button will be the keyboard space button. So select that, and for the controller, we're gonna add the button south. Okay, so add another binding, and right here search for south, and it will give you this south button south gamepad. Okay, select the first one. That's it. And if you want to select some other button, then you can do that as well. Then click on cross sign, then click on save. After that, go ahead and open up your input manager script, because we now need to read these input. So right here, let's first of all make a header, name this as input button flag or just flag. Okay, so right here we're gonna say public pool jump input. Then right here we're gonna say the exact same thing as we did for the B input. So I'm just gonna copy and paste that line right here. So player controls dot player actions dot jump dot perform, and right here we're just gonna say jump input. That's it. And for the jump input, we don't have to add the cancelled, because as you know that when we press the space button, it will just only happen once. Okay, and that's all. Now if you scroll down right here, let's create a method which will be by the name of handle jumping input. And in this, I'm gonna say if the jump input is pressed, then jump input will be equals to false. And right here we're gonna call the handle jumping method. So for now, let's leave this as it is and open up the player movement script. Let's scroll up right here. Let's add a header, name this as jump variables. The first one will be of type float. So we're gonna say public float jump height. This is gonna be equals to 4. After this, we're gonna create another float which will be by the name of gravity intensity. This will be equals to -15. After this, we will create handle jump, but before creating that method, we need to set this is jumping to false. Okay, so right here on the jump animation, click on add behavior, new script, Let's name this as reset is jumping. Let's open this up. Okay, and on state exact, where is it? Right here. Okay, we will uncomment that, and right here we just simply gonna say animator dot set bool is jumping. Okay, let's set this to false. That's it. Now get back right here. Okay, we have the variables. Now let's create a method. So we gonna say public void handle jumping. Okay, we will say if is grounded is true, then we will allow the player to jump. So we're gonna say animator manager dot animator dot set bool. Let's set the is jumping bool to true. Okay, after that we're gonna say animator manager dot play target anim. Let's pass the jump animation name to it, and then pass false to the is interacting, because when the player is jumping we don't want the player to move around. And let's check the animation name. As you can see, it is jump, so this should be jump as well. Okay, and on the animator manager, make sure that you make this animator public. Okay, because we are uh, using the animator right here, so it should be public. Now we will create a float by the name of jumping velocity, and this is going to be equals to mathf dot square root. We're going to say -2, multiply that by the gravity intensity, and multiply that again by the jump height. Okay, so this will move our player up in the air according to the jump height. Okay, then we're going to say vector3 player velocity. Okay, name this as player velocity. This is going to be equals to the move direction. Then player velocity dot y will be equals to jumping velocity, and then player rigid body dot velocity will be equals to the player velocity. Okay, then we will set the is jumping bool of the script to false, and after this we're gonna create one more method which will be set is jumping. It will be needing a bool as a parameter, and in here we just simply gonna say this dot is jumping will be equals to is jumping. Okay, now let me explain what we are doing in the handle jumping. So first of all, right here we check if the player is grounded before allowing a jump action. Okay, then right here we set the is jumping parameter in the animator to true to trigger the jumping animation. Okay, then in this line we play the jump animation using the animator manager dot play target animation method. Okay, then right here we calculate the initial vertical velocity, which is this jumping velocity, using physics formula for vertical motion under gravity. Okay, which is this formula mathf dot square root, we pass -2 and we multiply that by the gravity intensity and also the jump height. Then right here what we did is we update the player rigid body velocity, which is player rigid body dot velocity, to initiate the jump with the calculated vertical velocity. Okay, and then after that we set the is jumping to false to indicate that the player is no longer in a jumping state after initiating the jump. Then in this method, which is the set is jumping, right here we just simply update the is jumping flag based on the boolean parameter passed to the method. Okay, and that's it for this. Okay, and in the previous video I think I forgot to explain the handle falling and landing method, so let me break this down as well. Okay, this whole method. So let's start from this. Okay, as you know that this raycast hit type variable hit store information about the object hit by the sphere cast. Okay, then right here this raycast origin represents the origin point for the sphere cast, adjusted vertically by the raycast height offset. After this we have this target position. This basically store the target position for the player. Okay, then we check if the player is not grounded, and also we have added jumping, so we will now also be saying if the player is not jumping. Okay, so if that is the case, then we play the falling animation using animator manager dot play target anim if the player is not interacting with object. Okay, or you can say not moving on the ground or anything. After that we increase the in-air timer based on time dot delta time. After that we applies forces, which is leaping velocity first of all. So leaping velocity, forward force, and falling velocity multiplied by in-air time, which is the downward force, to simulate falling using player rigid body dot add force. So this basically creates a falling physics. Okay, after that we uses physics dot check sphere to check for the ground collision beneath the player within a radius of 0.3 and against the ground layer. Okay, after that we play the landing animation using animator manager dot play target anim method, and also we check if the player is not grounded and not interacting with any object. Okay, after that we adjust the target position vertically to match the hit point from the sphere cast, and we resets the in-air timer. Okay, then after that we set the is grounded flag to true if the sphere cast hit the ground, otherwise we set it to false. Okay, so this was all about the handle falling and landing method. Now we have also added jumping, so now let's set this up as well. Get back to the input manager script, and as you know that on the player movement now we have a method for jumping, so we're gonna say player movement dot handle jumping. Okay, and now whenever we press the jump input, it will play this handle jumping method. After this, let's open up the player manager, and right here in the late update, what we're gonna do now is we're gonna say player movement dot is jumping is equals to animator dot get bool. We want to get the is jumping bool, so get that from there, and then we're gonna say animator dot set bool. We want to set the is grounded bool to the player movement dot is grounded bool. Okay, So if on the player movement script the is grounded is true, then in the animator is grounded will be true, and if it is false it will also be false as well. After this, now we need to do one last thing is right here. As you know, we leave a comment for is jumping, so we're gonna set this up now. So if the player is not grounded and is not jumping, okay, and also right after this else condition we're now gonna add one more condition in which we're gonna say if the player is grounded and if the player is not jumping. Okay, so if this is the case, then what we're gonna do, we're gonna say if player manager dot is interacting or input manager dot move amount is greater than 0, then what we're gonna do in this case, we're gonna set the transform dot position, which is the player position, to vector3 dot lerp transform dot position. Then we're gonna pass the target position, and then we're gonna say time dot delta time, and then we're gonna say 0.1 f. Okay, and in the else we're gonna say that the position of the player will be equals to the target position. After this, in the handle rotation, when the player is jumping, we don't want the player to rotate. Okay, so let's set the is jumping. If that is the case, then simply return from there and don't rotate. That's it. And we can add the same thing on the handle movement method as well. If you want, you can just simply type this right here like this. Okay, but I prefer to do it in the method, so it's your own choice. Now let's save the script and get back right here. As you know, we have these 7 errors, so let's start from the first one. Player movement 60 and 92. Here is the same error. So right here it shows that we don't have the is jumping because we didn't add is jumping. Okay, so make sure that you add is jumping at the top in the movement flags, and when you do that all of the errors will be gone. Okay, and we can now test it out. Right here guys, on this transition make sure that you add is grounded true. Okay, because when it is true we're gonna land. I've moved down the player back to the ground so that we can see how does it looks now. So here is the player. Now as you can see the player is shaking, and if you press the jump button, as you can see jumps gets equals to true, but no animation is playing, as you can see. Okay, and this is because in the handle jumping method this method is not called anywhere, and of course if it is not called anywhere then the handle jumping will not be called. Okay, and also I have added this line, so make sure that you add this line as well to this method. Okay, this is the only change I have did. And also copy this method name and make sure that you put it right there in the handle all inputs. That's it. And after that let's play the game again to see if it works now or not. Okay, so as you can see the player is on the ground. Okay, so the player is jumping, but not fully in the air. Let me increase this. Let's increase it to 35. So the player gets stuck in the air, as you can see. Okay, the player is getting stuck, and also the player is performing this shaking thing. I don't know why. Let's turn on the gizmos. Alright. Okay, doesn't work. Now if we perform it, okay. So now as you can see the jumping is fixed. Just remove the as exact time from this transition. Okay, and now as you can see the player jumps back to the ground perfectly fine, but if you notice there is this vibration in the player body, so we need to stop this. Hello guys and welcome back. So in this video we will fix this issue with our player. As you can see the player is shaking when on the ground. So in order to fix this we need to change this rigid body interpolate to none, and when you do that start the game again. Now as you can see that shaking is gone and we can also jump perfectly fine, as you can see. Okay, but if you notice there is now two more issues. As you notice the jump animation is not being played fully. Okay, as you can see the player just move up to the sky, and also now when we walk there is a little bit shaking in the player movement, as you can see. Okay, so let's first of all fix the movement issue. For that you just have to change the camera follow speed to 0, and now as you can see the player movement is again smooth. Okay, and if we jump, okay, we need to now fix this issue. So in order to fix this, make this 0. Okay, now if we click on animator right here, select the jump animation, and let's cut this starting part. As you can see this whole starting area, because right here the player is not doing anything much, so we're gonna just cut that part till here. Okay, click apply, and now when we play the game, as you can see the player is not shaking anymore, the player walking is smooth. And now if we jump, as you can see the player can jump as well, as you can see. Okay, you can increase the jump height and jump intensity if you want. So let's make it 55. Now 55 is a lot, so I think 45 will be a good value then. Okay, so 45 is a good value for this. Okay, now as you can see everything works perfectly fine. Okay, hello guys and welcome back. So in this video we will be adding the traffic AI in our game. Okay, we will add AI characters and they will walk using a waypoint system in the whole environment. Okay, so for the AI character models you can use whatever models you want. Just open up miximo.com and from here you can select these different types of characters and you can download their animations as well. But to save our time I have created this Unity package in which we have all of the AI character setup. Okay, their animations and the character. Okay, and also these all characters are from miximo.com and all of the animations as well. So if you go ahead and download this package and then add it in your project, okay, it will give you this window, and as you can see it shows right here AI characters, in which we have all of the characters and animations. So let's just simply click on import, And when it is imported right here, as you can see, we have the character and the animation right here. Okay, and also on each of the character, the animator is already set up. Okay, but if you are using some other animations and some other character, then you can set up your animator like this. Okay, first of all, add your walking animation, then your dying animation, and make a transition from walk to dying, in which set the condition die to true. Okay, create a parameter die right here and then set it to true right here. Okay, so whenever the player dies, the transition will go from walk to dying animation. That's it. Okay, so as you can see, these are all of the characters. Now what we're gonna do is we will go ahead and create our waypoint system. So let me first of all explain how our waypoint system will work. Okay, so consider this as waypoints. Okay, 1 2 3 4 5. So what we're gonna do is we're gonna create a waypoint script which will be automatically attached to each of the waypoint, and on each of the waypoint the information will be stored to the next waypoint and the previous waypoint. So for example, if the waypoint script is attached to this waypoint, okay, then for this the next waypoint will be this second one, and its previous waypoint will be the last one. Okay, right now the waypoints are in straight line, but in our game, of course, we will create our waypoints in a way so that they are like this. Okay, like all of the animations are connected. Okay, so now let me explain it back again. Okay, so on each of the waypoint we will have a waypoint script in which the information will be stored to the next waypoint and the previous waypoint. So on this one, the next waypoint will be this and the previous waypoint will be this one. Okay, and now for the second one, the next waypoint will be this third one and its previous waypoint will be the first one. Okay, then the same for this one, its next will be this fourth one and its previous waypoint will be the second one. Okay, so if the player start from this position, then the player can go in the forward direction like this. Okay, in all of these waypoints the AI characters can walk, and also we will make some AI characters which will walk in the previous waypoints like this. Okay, so this is how our waypoint system gonna work. So let's go ahead and first of all add these AI characters in our game assets, and when you do that, then open up the scripts folder. In here create another script. Let's name this as AI characters, and in here we will create a waypoint script. Okay, then let's just open this up. Let me close the other scripts for now because we don't need them now. Okay, and in here create a header in which we will say waypoint status. Okay, so as I told you, we will store information to the previous waypoint and also to the next waypoint. So we're gonna name this one as next waypoint. Okay, and these previous and next waypoint will be added automatically. Okay, we will create a system in which we will be just creating waypoints using a button, and all of these references will be added automatically. Okay, we don't have to do that manually. Now we will also gonna give each of the waypoint some range. Okay, the range between the previous waypoint line and the next waypoint line, because of course if they are on top of each other, then the characters will collide with each other. Okay, so we want some space between them. So for that we're going to create a range from 0 to, let's just say, 10. And then we're going to create a float right down below. Name this as waypoint width, and this will be equals to by default as 5. That's it. Then create a vector 3 by the name of get position. Okay, and in here now we want to give some space, okay, using the waypoint width. So create a vector 3 by the name of minimum bound, and this is going to be equals to transform dot position plus transform dot right, multiply that by the waypoint width and divide that by 2. Then copy this line, paste it down below. Now this will be the maximum bound, and now instead of the minus sign, a plus sign, we're going to use minus sign because we can't use transform dot left, and then everything else will be the same. Then we're going to say return vector 3 dot lerp. Let's pass the minimum bound, then the maximum bound, and then we're going to say random dot range. Let's pass 0 and 1. That's it. So now let me explain what we did right here in this get position method. So this get position method returns a random position within the bounds of the waypoint width, okay, minimum bound and maximum bound. Between this minimum and maximum bound, it returns a random position, okay. And right here we just simply calculates the minimum and maximum bound based on the waypoint position and width, okay. And then we uses this vector 3 dot lerp to interpolate between the minimum bound and the maximum bound based on the random values between 0 and 1. Effectively, this return a random position within the waypoint width, okay. So this can be from 0 to 1 or from 0 to 2, okay. You can change this according to your own liking. That's it. After this, as you know that we will be creating a system in which when we click on a button like create waypoint, then waypoint will be created, okay. So we need to create that whole system. For that, right here in the assets, as you know that we have this editor folder, but if you don't have this editor folder, then you can just create one, okay. But since we have this editor folder, so what we're gonna do in here is we're gonna create a C# script by the name of waypoint manager window. Let's open this up and I will tell you what we will be doing in this is we're gonna create a window for our waypoints, okay, just like we have the scene window and the game window and animator window, okay, in this similar manner. Okay, as you know that in Windows we can also open up whatever window we want. For example, in the journal we can open up scene or whatever window we want. So in the same way we're gonna create our waypoint window now. So for creating it, first of all at the top we need to type using Unity editor and then change this from mono behavior to editor window. Okay, then after this we're gonna create a menu item. So we will create a new option which will be by the name of waypoint, and then in the waypoint we're gonna have a sub menu which will be by the name of waypoints editor tools, okay. Then when we click on this waypoint editor tools, then we want to open up a window. So we're gonna say public static void show window, and in here we're gonna say get window waypoint manager window, and we can name this window as well. So let's name this as waypoints editor tools. Okay, save the script, get back to Unity, and now as you know, when we get back to Unity, right here we now have this waypoint menu right at the top, and if you click on it we have this sub menu now, waypoint editor tools, and if you click on it, it will open up this window which will be by the name of waypoint editor tools. So now let's drag and drop this window in there with the inspector, and now right here we're gonna create our buttons, and then using that buttons we can create our waypoint. Okay, but we're gonna do that in the next video. Hello guys and welcome back. So now in this video we will further work on our waypoint manager window script. Okay, so what we're gonna do is right here we're gonna make a reference to a transform. Okay, and let's name this as waypoint origin. Okay, and as you guessed it by the name, it will be the waypoint origin. Okay, we will create a game object and name it as AI character waypoint, and then we're gonna assign that game object to this. Okay, and then when we assign it, we will then start creating waypoints inside this waypoint origin. Okay, so after this, create a on GUI method in which we're gonna create a serialized object, name this as obj, and this gonna be equals to new serialized object this. Okay, then we're gonna say editor GUI layout dot property field. In here we will say obj dot find property, and we're gonna pass this name in here. Okay, and then we're gonna say if the waypoint origin is null, then we're gonna show a message in the window that please assign a waypoint origin transform. Okay, so editor GUI layout dot help box, and in here type please assign a waypoint origin transform. Okay, and then we're gonna set the message type to warning, and else if the waypoint origin is assigned, then as you know that we're gonna then start creating waypoints. Okay, so for that we're gonna say editor GUI dot begin vertical, we want to create a button. So right here we're gonna call a method which will be by the name of create buttons, but for now we don't have this, so don't worry about it. Okay, we will create this method. Right here just simply type editor GUI layout dot end vertical, that's it. After this on GUI, let's create this method which is create buttons. Okay, in here let's create a button, so we're gonna say GUI layout dot button, name this as create waypoint. Okay, And when this button is pressed, we're gonna create a waypoint. But for now, we're gonna leave a comment and add a if condition to this. Okay, so if this button is pressed, we're gonna create a waypoint. Okay, and right here, change this from editor GUI to editor GUI layout and save the script. Get back right here. And as you can see, we can't see our button, not the transform. It is due to this, so make sure that it is on GUI in capital. That's it. If you save the game and get back right here, you will notice that right here it says please assign a waypoint origin transform. Okay, and now for example, if we create an empty game object right here, okay, let's move it to the ground. For example, right here, okay, this will be the sidewalk area. So I'm gonna do it right here, move it to the ground. That's it. Now name this as waypoint origin or AI character waypoint origin. Okay, drag and drop it in there. And as you can see, we can't drag and drop it because we are not updating the property. Okay, so in order to do that, right here at the bottom, now you need to type obj dot apply modified properties. And then if we get back right here, as you can see, it is showing this warning. But now if we drag and drop this, as you can see, it shows this create waypoint button. And now we will be able to create waypoint in here. Okay, but for that we have to type a method so that we can be able to create waypoints inside this origin one by one. So now in this video we will create the waypoint, or you can say we will connect the waypoints, okay, the next waypoint and the previous waypoint references. So right here, call a method by the name of create waypoint. Okay, let's copy this and paste it down below. Then in here we're going to create a game object by the name of waypoint object. That's going to be equals to game object waypoint plus waypoint origin dot child count type of waypoint. Okay, let me complete this code. Okay, let me type this all, and then in the end I will explain what we are doing in here. Okay, now the waypoint object dot transform dot set parent waypoint origin false. Okay, then we will say waypoint equals to waypoint object dot get component. We want to get the waypoint script, and now we're gonna say that if the waypoint origin dot child count is greater than 1, it means that if we created a waypoint, okay, then waypoint dot previous waypoint will be equals to waypoint origin dot get child. We want to get the child count minus 2 dot get component, get the waypoint script from there. That's it. Then waypoint dot previous waypoint dot next waypoint equals to waypoint. Then waypoint dot transform dot position will be equals to waypoint dot previous waypoint dot transform dot position. Then waypoint dot transform dot forward will be equals to waypoint dot previous waypoint dot transform dot forward. Okay, so now if we start from the first line, right here we just simply create a new game object, okay, named as waypoint plus the child count, where child count is the number of the children of the waypoint origin object. Okay, then we adds a waypoint component to the newly created waypoint. After this, right here we set the parent of the waypoint object to waypoint origin while maintaining its local position, rotation and scale. And you will be thinking, where we say all of that right here, this false indicates not to change local values. Okay, then right here on the third line we retrieve the waypoint component attached to the waypoint object. Okay, then right here we are connecting waypoints. So first of all we check if there is more than one child under the waypoint origin. So if it's true, then we connect the newly created waypoint with the previous waypoint in the sequence. Okay, then we sets the previous waypoint of the new waypoint and updates the next waypoint of the previous waypoint to the point to the new waypoint. Okay, then after that we positions the new waypoint at the same time as the previous waypoint and aligns its forward direction with the previous waypoint forward direction. Okay, so let me tell you, overall this method creates a new waypoint game object, sets its parent, retrieve its waypoint component and connect it to the waypoint sequence. If there is a previous waypoint, this process allows for dynamic creation and management of waypoint in game environment. Okay, now if we simply save the script, but before that change this W to capital, because as you know the waypoint script class name is waypoint. Okay, and now when we check it right here you will understand what I mean. Okay, so now if we create a new waypoint, as you can see inside this parent it's created this waypoint, and if you check it, it assign the waypoint script to it. As you can see, previous next waypoint that is missing, but now if we create another one, check the inspector again. Now as you can see in the waypoint 0 the next waypoint is 1, and if you check waypoint 1, in the waypoint 1 the previous waypoint is 0. Okay, so this is what we type in the code. Now if we create two more, check the second one. As you can see, the second one previous is 1 and next is 3, and if you check the 3, the previous is 2 and the next is missing, so we're just gonna drag and drop this, and in 0 we're gonna drag and drop that. In this way we will uh, create our waypoints and connect them. Okay, but for now, if you notice, when we create a new waypoint, as you can see, that newly created waypoint is not selected automatically. So we want that whenever we create a waypoint, we want that waypoint to be selected like this. Okay, and in order to do that, for that we just have to type right here that selection dot active game object equals to waypoint dot game object. Now if we create a new waypoint, as you can see, that waypoint is created automatically, as you can see. Okay, if you notice it, it is already selected. If you create another one, as you can see, it is selected. Okay, now once we are creating these waypoints, now in the next video what we're gonna do is we're gonna visualize our waypoint, okay, so that we can see where our waypoints are. Hello guys, and welcome back. So now in this video we will be visualizing our waypoint. So for example, if we create a waypoint, okay, this is our waypoint. What we want to do with this waypoint is we want to create a sphere around the waypoint area, and as you know that on each of the waypoint we have this width, so we also want to show the width of the waypoint. Okay, and when we increase or decrease the width, we will be increasing and decreasing that line as well. Okay, so for that, create a new C# script right here by the name of waypoint editor. Let's open this up, and right here we're gonna remove the mono behavior, and at the top we're gonna say using Unity editor. Okay, and also we want to initialize this whenever the game, or you can say whenever the project is loaded. Okay, so we're gonna say at the top initialize on load. Okay, now in here let's type draw gizmos, then we're gonna say gizmos type. So the gizmos first type is non-selective, and then we're gonna say gizmos, actually just gizmo, and right here as well, gizmo type dot non-selective, and then gizmo type dot selected, and then gizmo type dot pickable. Okay, so these are the types. Then let's create a public static method by the name of onDraw scene gizmos. This will take a waypoint as a parameter, and then gizmo type. After this, we're gonna say if the gizmo type and gizmo type is dot selected. Okay, we actually need to add two round brackets, and if it is not equals to 0, then we're gonna color it as blue. So gizmos dot color equals to color dot blue. So what this means that whenever we click on our waypoint, then the waypoint gizmo color will be set to blue. Okay, else if we didn't select it, then we want the color of it to be a little bit lighter blue. Okay, so gizmos dot color will be then equals to color dot blue, and multiply that by 0.5. Alright, so this is for the color. Now let's draw the actual sphere around the waypoint. So we're gonna say gizmos.draw sphere waypoint dot transform dot position, and let's pass a width to the sphere as 0.5. Okay, so when we select this sphere, its color will be blue, and if we don't select it, it will be a little bit lighter blue. Okay, now let's draw the lines. Okay, but first let me show you what this code means. But make sure that at the top you type I right there. Okay, initialize on load, and right here remove this S from there. Okay, because it is just gizmo. Then if you save the script and get back right here, now as you can see, here is our waypoint. Okay, as you can see, this is the sphere, and when it is selected it is blue, and when it is not it is lighter blue. Okay, and if we create another one, here it is, this is the next one. Okay, now we want to show its width. Okay, like what is the width of this waypoint. As you can see, it is 5, so we want to visually show it. And also guys, make sure that your gizmos are turned on, or else you will not be able to see it. Okay, make sure that you turn on these gizmos. Now for the line, what we're gonna do is right here we're gonna say gizmos dot color will be equals to color dot white. Okay, this will be the color of the width. And now let's draw that line. So we're gonna say gizmos dot draw line, and in the round brackets let's draw the line. So first of all we're gonna say waypoint dot transform dot position plus waypoint dot transform dot right, multiply that by the waypoint dot waypoint width, and we want to take the half of the width because we will show half of the width on the right side and then half of the width on the left side, and it will become a full width. Okay, so if you save the script and get back right here, you will notice that this is what I was talking about. As you can see, we have this width line now, and if we try to increase the value, as you can see, it get increased like that. Okay, so this is our waypoint visualization. Okay, for this sidewalks, the 5 width value is enough, as you can see. Okay, now what we want to do is we want to show the previous waypoint line and the next waypoint line. So let's start from the previous line. Okay, we will color our previous line as red. So we will say if the previous waypoint is not equals to null, okay, then color it as red. So we're gonna say gizmos.color equals to color.red. After this we're gonna say vector3 offset, and let's set the offset of this. So the offset will be from waypoint.transform.right till the whole width of the waypoint. So waypoint width. Okay, and divide that by 2. So what this means that it will show the previous waypoint line on the right side. Okay, so this is what it will do. And also we want that previous line to go from the current waypoint to the previous one. So for that let's create a offset 2 as well. So offset 2 will be equals to waypoint dot previous waypoint dot transform dot right, multiply that by waypoint dot previous waypoint dot waypoint width. and divide that by 2 as always. Then once we have all of the angle set up, now let's draw the actual lines. So we're gonna say gizmos.draw line. So we will draw the line from waypoint.transform.position offset till the waypoint dot previous waypoint dot transform dot position offset to. Alright, now this is for the previous one. So if you save the script and get back right here, now as you can see the waypoint is on that side, okay, the forward vector is on this side. So now as you can see here, according to this, now the right side is this one. So as you can see from the right side, waypoint width, as you can see, it is drawing a red line to the this next waypoint right side, okay. So this is what this angle means. Now let's do it for the next waypoint. So I'm gonna copy that, paste it down below. Right here we're gonna say if the next waypoint is not null, we're gonna color it as green, and this time we want the next waypoint line to be on the left side. So right here we're gonna use the minus sign, okay, and then right here we can also use the minus sign, okay, and in here everything else will be the same. That's it. If you save the script and get back right here, you will notice that okay, it is not showing the line. So let's go ahead and create another waypoint. Now as you can see that waypoint is now showing, okay, as you can see. So if you check the inspector now, as you can see, the first next waypoint is waypoint 1. So as you can see from 0 to 1 there is this green line, okay, and on waypoint 1 the next one is the third one, I mean second one, this waypoint 2. So right here we can't see the line, but when we create a waypoint, okay, then it shows the line, okay. So in order for the green line to be shown, make sure that the previous and next waypoint is attached. Now this one, the next waypoint is missing. So if we create the waypoint, as you can see, it is now showing. So the third one, next waypoint is fourth, and the fourth previous one is third. And if you check the second one, its next is 3. So from 2 to 3 there is this line, okay, and right here the next waypoint is missing, so that's why it is not showing that transition. Okay, so this works perfectly fine. Now we can see the previous and next waypoint, and what we're gonna do in the next video is we're gonna make a whole workable area right here for our AI characters, okay. So with this done, let's end this video right here. Okay, so in this video we're gonna create the waypoints for our AI characters, okay. So what I'm gonna do is I'm gonna create waypoints, for example from this position I will go in this direction, then right here we will turn and then turn right here, and we will move the waypoints right till this point, and then from here we will move to this waypoint back again, okay. And if you want to extend this, then you can do that as well in your whole environment, but I'm gonna do it for just this area so that you guys can know how you can add your own waypoints, okay. So first of all I'm gonna rotate this on 180 and then click on waypoint editor tool. Let's create a waypoint. So this will be the first waypoint. Let's create the second one, move it in that direction, select the waypoint, let's move it in here, okay. Now create another one, move it forward, then create another one, move it right here, create another one, and let's move it till this point, and then from here we're gonna create one more till this point, then the next one will be right there. Okay, now create one more, move it right here like this, and we need to rotate this in this direction so it is 90. Okay, rotate it, but first let's move this right here, then move it right here actually. Okay, so now move this right there, and then let's create another one, move it in the straight direction now. Okay, so move it right here, then create another one, and we need to move this till this side so that it doesn't go inside the building. Okay, create another one till this point. Alright, so here it is. Now what we're gonna do is we're gonna rotate this on 180. Okay, move it right here, then let's create in this direction now, create another one, move it till that point, and there create one more. Alright, it is taking place, so we're gonna move from here till there and then right there. Okay, so let's move this one right here, then move it again till that point. Create another one and move it right here. Now we need to move it on one minus 90. Okay, so it is right there. Let's create another one, move it in the forward direction now. Create another one, move it in the forward direction. Okay, till this point. And now from here you can either go that way and then join it with here, or you can just connect it in this direction. Okay, so I'm gonna do it in this direction just simply because now you guys know how you can create waypoints. Okay, so this is the waypoint. I'm gonna create one more right here. Okay, and let's rotate this on 90, actually 180. Why is it still looking at that side? Okay, we just have to make it 0. Okay, now move it right there, move this one right here, and this one should be like this. Okay, so now as you know that in the inspector all of the waypoints next and previous waypoints are added, but if you check the last one, the next waypoint is missing, and and the waypoint 0 previous waypoint is missing. So if you select waypoint 0 in the previous one, we're going to drag and drop the 20. As you can see, it is connected, and if we select 20 in here, we're going to drag and drop the 0, and now as you can see they are connected just perfectly fine, and we can move it like this. Okay, So all of them are now connected. Okay, the next thing which we will be doing now is adding the AI characters. So in the next video we're gonna add AI characters and then they're gonna walk inside this Waypoint system. Okay, hello guys and welcome back. So now in this video we will be creating a script for our AI characters, and using that script the AI characters will walk between these waypoints. Okay, so let's start from the scripts. First of all, in the scripts folder, in the AI characters folder, then go ahead and create a new C# script by the name of character navigator script. Okay, then let's open this up, and on this script what we're gonna do is we're gonna create a header by the name of character info. We're going to create a float by the name of moving speed, then another float which will be by the name of turning speed, then the next one will be a float by the name of stop speed, then we will create a private float and this will be the character health. Actually right now we are not dealing with any of the character health things, so we're gonna just leave this as it is for now. Okay, and we're gonna create another header which will be by the name of destination variable. Right here create a vector 3 by the name of destination, then create a bool by the name of destination reached, and then we will be needing a reference to the animator, and then the next one will be actually a private float. It will be by the name of waypoint timeout, and that should be 30 seconds, and then another float which will be current timeout. This will be 0, and actually let's make this one as public. Okay, now once you add all of these variables, save the script, get back right here, and from the game assets open up AI character, then open up the first character, drag and drop it right here. Let's first of all check the character height. As you can see, the character height is a little bit smaller than the player. So what we're gonna do with this is select the character, make it 1.2, 1.2 and 1.2, okay, to make the character as similar to the player, okay, as you can see. Then when you add the character, click on prefab, unpack completely. Let's name this as 1 because this will be our first AI character, and as you know we need to add the animator, so just drag and drop this animator right there. Okay, then as you can see this player can walk. This is the death animation. This is the another death animation. Okay, so you can add whatever you want. Now on this character we need to add a rigid body. Okay, and on the rigid body let's stop these constraints, and then let's add a capsule collider, and after this we're gonna add the script. So go inside scripts and let's drag and drop this script at the top. Okay, here it is. Now you can check the animator of this character. Okay, here it is. So we have the walking animation and the dying, and the parameters, we have the type parameter set to true when the player make a transition from walking to dying. Okay, so now on the script, let's make a walk method, okay, in which we will allow the player to walk between the waypoints. Okay, so first of all, we're gonna check if the transform.position is not equals to destination. Okay, then we're gonna say vector3 destination. Let's name this as destination direction. I'm gonna explain this code, but first let me complete typing it. Okay, so destination will be then minus transform dot position, then destination direction dot y will be equals to 0 because we don't want the player to move up in the sky, and then destination distance float will be equals to destination direction dot magnitude. Okay, then we're gonna say if the destination distance is greater than or equals to the stop speed, then we're gonna add turning to our player. Okay, so that the player can turn when there is a turn in the waypoint. So first of all, we're gonna set the destination reach to false, then we're gonna create a quaternion by the name of target rotation, and this is gonna be equals to quaternion dot look rotation. Let's pass the destination direction into this, and then we're gonna say transform dot rotation equals to quaternion dot rotate towards transform dot rotation, then target rotation, then turning speed, and multiply that by time dot delta time. Okay, then let's move our player. So for moving it, we're gonna simply say transform dot translate vector3 dot forward, multiply that by the moving speed, and then make it time dependent. So we're gonna say time dot delta time. Okay, and else if the player is not moving, not rotating, it means that the player has reached the destination. So we're gonna set this to true. Okay, after this, let's create another method. So public void, name this as locate destination, and this gonna be requiring a vector3 by the name of destination. Then we're gonna set this dot destination equals to destination, and then destination reach will be false again, and let's set the current time out to 0. Okay, so now we need to pass our destination to this locate destination. So for that we have to create another script, and as I told you, don't worry, I will explain this in a moment. So right here, create a new script by the name of Waypoint navigator, Now on this script, we're gonna add a header by the name of AI character, and in this we're gonna create a reference to our character navigator script. Name this as character. Then we're gonna create a public waypoint type variable by the name of current waypoint. Then we're gonna pass we're gonna create an integer by the name of direction. Okay, and using this direction integer, we're gonna set the AI character to either walk in the next waypoint or the previous waypoint. Okay, and in that way it will make the traffic more realistic, because some of the player will be moving forward and some of them will be moving backward. Okay, so save the script, get back right here and drag and drop this waypoint navigator script on the character like that. Okay, drag and drop this script in there, and for the current waypoint we're gonna add this waypoint. Okay, so select the character, and for the current waypoint pass this 0 waypoint. Okay, and now since these two are on the same game object, so what we want to do, we don't want to manually add the character like this. Okay, just delete it. We want to add this reference automatically, and also we will be adding it for the current waypoint when we create a character spawning system. Okay, but for now leave this as it is. Now in the awake method, let's attach the character navigator script automatically. So for that, in here we're gonna say character equals to get component. We want to get the character navigator script. Okay, after this we're gonna say start, and in the start we want to set this direction integer either to 0 or to 1. Okay, so direction will be equals to mathf dot round to integer, then random dot range 0 and 1. So if it is 0 it will be previous, and if it is 1 it will be then the next waypoint. Okay, and right down below say character dot locate destination, and now to this locate destination, as you know, it requires a vector3 destination, so we're gonna pass the destination from this script to this method. Okay, so for now let's leave that as it is, and let's add an update method in which now we will move the player either in the next or previous waypoint, and that will be the player destination as well. So first of all we're going to check if the character dot destination reached is true, and if it is true then we want to provide a new destination. And as I told you, if the direction value is 0, then it will actually be the next waypoint, and if it is 1 it will be then the previous waypoint. Okay, the player destination will be then the previous waypoint or either the next waypoint. So right here we're gonna say if the direction is equals to 0, then the player destination is the next waypoint. So we will add a if condition again, in which we're gonna save the current waypoint dot next waypoint is not equals to null. It means that if the next waypoint is attached, okay, in that way, then we're gonna move our player. So current waypoint equals to current waypoint dot next waypoint. Okay, else what we're gonna do, we're gonna say current waypoint equals to current waypoint dot previous waypoint. Okay, if there is no next waypoint available, then we just gonna simply provide the previous waypoint. That's it. Then we will set the direction to 1. if the next waypoint is not available. Okay, now let's do this for the previous waypoint. So we're going to say else if the direction is equals to 1, then in this case what we're going to do, we're going to do the same as we did right here. So let me copy and paste that, and right here we're going to say if the previous waypoint is not null, then the current waypoint of the player will be current waypoint dot previous waypoint. Okay, and if the previous waypoint is not available, then we're gonna add the next waypoint. We will, I mean, make the player walk in the next waypoint, and we're gonna change the direction to 0. Okay, and now we actually need to move our player. So in this if condition, just simply type character dot locate destination. Let's pass the current waypoint dot get position. That's it. And right here we're gonna type the same thing, current waypoint dot get position. Okay, and right here in the start method, the reason we added this is because when the game start, the current waypoint of the player will not be added. Okay, so that's why when the game start, we just give the player the position, and also then when the player reaches each of the waypoint, then we change the waypoint as well and move the player. Okay, so now the position is being passed to this. Now on this script, what we're gonna do is we're gonna add an update method, and in here just call the walk method. And now let me explain this whole thing. So right here, first of all, we check if the current position of the object transform.position is not equals to the destination position. Okay, if that is the case, then first of all right here we calculate the direction and distance to the destination point. Then in here we check if the distance to the destination is greater than or equal to the stop speed, and if so, then we set the destination reached to false, rotate the object towards the destination using quaternion.rotate towards, and move the object using transform.translate. And if the distance is less than the stop speed, then we set the destination reach to true. Okay, in the else condition. In this method, we first of all update the destination field with the provided destination parameter. Okay, then we set the destination reach to false to indicate that the destination has not been reached yet. And then right here, for now just ignore this current timeout, okay, because I will explain this in the upcoming videos. And as you know that we are passing the destination from this script. Okay, so right here it is simple. First of all, we check if the destination is reached, then we give the player a new destination. Okay, and to make the traffic more realistic, we added this direction thing, in which if the direction is 0, then we will give the player the next waypoint, and if the next waypoint is not null, then as you know it is next waypoint, and if it is null or not provided, then it will be previous. And else if the direction is 1, then we provide the previous waypoint, and if in any case the previous waypoint is null or not provided, then we give the next waypoint so that the player don't glitch or stop walking. Okay, and right here we are just simply passing the position, or you can say the destination, to this script right here. Simple as that. Now if we save the script and get back right here, as you know that the current waypoint is automatically added to this and everything else as well, we just need to set the moving speed. So let's set it to, let us say 0.7. Okay, and that's it. Alright, let's now start the game. And now as you can see, the character is walking, and if you notice, the current waypoint is 0. So when he reaches 0, now as you can see, from there the current waypoint changed to 1, and now the player is walking towards that waypoint. And we actually need to change the speed according to the animation, so let's make it 1.2. Okay, it is still slow. Let's make it 1.5. Okay, so 1.5 is a good value for this character animation, as you can see. And now the character current waypoint is being changed, as you can see. Okay, now stop the game, make this 1.5, and now in the next video we're gonna create a spawning system in which we will spawn our AI characters on each of the waypoint and make them walk in all of them. Okay, so see you guys in the next one. Hello guys and welcome back. So in this video we will be working on our AI spawner script, because right now we are adding the characters manually one by one. So we don't want that. We want to create a script in which all of these characters will be spawned automatically. Okay, so first of all, let's set up all of the other characters in the same way as we set up our first one. So let me add the second one now. Let's change the size of this second one. Okay, let's make this 1.1, and then let's click on prefab, unpack completely, name this as 2. Then let's go ahead and add the third character. Make it 1.2. Click on prefab, unpack completely, rename this to 3. Then let's add the fourth character. Make this 1.1. Oh, let's just make this 1.22, and then click on prefab, unpack completely, name this as 4. Then we have the fifth character, so this will be 1.28, 1.28, and 1.28. Actually make it 1.8. That's it. Now click on prefab, unpack completely, and name this as 5. Then we have this other character, sixth one, so click on, actually first resize it to 1.1, and then click on prefab, unpack completely, and name this as 6. Then we have the seventh character, so drag and drop it, change it to 1.2, and name this now as 7. Okay, so now we have these characters. Now what we're gonna do, we will click on our first character, copy the first script, select all of these character, and then click on paste component as new. Then select the first one again, click on this copy component, copy the waypoint navigator script, select all of them, and click on paste component as new. Then select the first one, copy the animator from there, select all of the character, click on paste component as new. Then the rigid body, paste it right here. Then the capsule collider, so copy it and paste it on all of them. Okay, so now as you can see, these will be the characters. Now for the first one, everything is set up. Now let's select the second one. Let's move the second one right here. Okay, for the animator, we will add this animator, and right here we will change the controller. So if you open this up right here, okay, drag and drop this second controller in there and the avatar as well. So for the avatar, we can go inside the animation pack, and as you know that the animation of this second character are generic, so we don't need any avatar on this. Okay, so we can just delete it. Alright, let's open up its animations and drag and drop this second character. It's not playing that, neither this one, neither this one. Because it is the first character animation, select the second character animation, and now as you can see, it is playing perfectly fine. Okay, so once you do that, then as you know that this character will be attached automatically, we just now need to change the waypoint. So for this character, the waypoint will be 20. So drag and drop 20 waypoint in there. Okay, now let's set up the third one. So let's move the third one back there. Okay, now drag and drop the animator in there. And for the avatar, let's check the third one. So the third one is also generic, so we don't have to add any avatar. Okay, remove that avatar. And that will be it for this one as well. If we check the animation, drag and drop the character, here it is. Okay, now let's check the fourth one. So we can move the fourth character back there. Move the fifth one to somewhere right there. And then we have the sixth one. So move sixth one right here. And the seventh one will be in that spot. Okay, so we did the third one. Now let's do the fourth one. So for the fourth one, the waypoint will be this waypoint 4. So drag and drop the waypoint, drag and drop the animator, and for the fourth one, let's check the animation. Okay, it is generic, so we're gonna remove the avatar. That's it. Now let's check the fifth one. Here it is. Move it to that waypoint. Okay, now add this waypoint to the fifth one. Drag and drop the animator. Check the fifth one. It is also generic, so we're gonna select the fifth one and remove the avatar. Now the sixth character, here it is. First of all, drag and drop the waypoint, so drag and drop that, then the animator, and then if you check the animation, they are generic, so remove the avatar from this one as well. Then the last, which is 7. So for the seventh character, the waypoint will be this one. Okay, which is 18. So drag and drop the 18 waypoint in there, drag and drop the animator, and for the animations, let's check it out. They are generic as well, so remove the avatar. That's it. Okay, and as you know that it takes a lot of time to set up all of these characters one by one and putting them in each of the waypoints, so that is the reason why we will be creating the AI spawner script in which we will spawn these characters in any random waypoint and then they will walk from there. Okay, so now everything is attached to all of the characters. Let's play the game and see how does they walk. As you can see, they are walking perfectly fine. This one is not playing the animations. Alright, let's check the other one. This one as well, playing the animations. this character as well. Okay, so let's check that which characters are not playing the animations. So the first one is playing it, second one as well, third one, fourth, fifth, sixth, and seventh. They are not playing the animations. And the reason behind this is, if you notice, in the first one the controller is 1, and in the second one the controller is 2. But in the third, fourth, fifth, sixth, and seventh, the controller is still 1. So we need to change the controller. So if you go inside the third character animations, drag and drop this controller right there. Then the fourth one, so drag and drop the fourth controller. Then the fifth, so select the fifth character, drag and drop that, select the sixth character and drag and drop that. Then the seventh, so drag and drop that in there. And also let's rename this to 6 and this one to 7. Now let's play the game again. Check the scene view. Okay, as you can see, this one is working perfectly fine. This one as well. Check this one. Now as you can see, they are all working. For this one, make the speed 1.3 or 1.2. This one it is perfectly fine. Let's check this one. This one will be 1.1. This will be 1.3. This one will be 1.1 as well. Okay, so 1.2, 1.1, 1.3, 1.1. So stop the game, select this one. This is 1.2. This one is 1.1. This one is 1.3 and the seventh one is 1.1. That's it. Now we are ready to create our AI spawn script. So before creating that, let's open up the AI characters first folder and drag and drop this first character so that it creates a prefab of it. Then open up the second folder and drag and drop the second character, then the third, then fourth, then the fifth one, then sixth and seventh. So make the prefab of all of these characters and then we can delete these characters. And now in the next video we're gonna add the AI spawner script. Hello guys and welcome back. So now in this video we will be adding the AI spawner script. Okay, so first of all go inside scripts, AI character, and in here create a new C# script by the name of AI spawner. Select the AI character waypoint origin, drag and drop the script. Okay, open this up and right here at the top we will create a public game object array by the name of AI prefabs. Then we will create a public integer by the name of AI or just AI2 spawn. Okay, now let's change this update method from update to spawn and make it a enumerator. In here create an integer by the name of count which will be equals to 0. Then add a while loop in which we're gonna say if the count is less than the AI to spawn. Okay, then what we're gonna do, we're gonna create an integer by the name of random index and we want to select random AI prefabs from this array and want to spawn them. Okay, so we will pass 0 for the first one and for the second one we're gonna pass the AI prefabs array. Then game object obj equals to instantiate AI prefabs random index. Okay, then create a transform by the name of child, which is going to be equals to the transform dot get child, then random dot range 0, then transform dot child count -1. How is this? We're gonna say obj dot get component. Let's get the waypoint navigator script, and from that script we want to get the current waypoint and set that equals to the child dot get component waypoint. Okay, then obj dot transform dot position will be equals to child dot position. Then you will say yield return new, wait for seconds. Okay, and right here let's add an integer by the name of timer, and right here we will say timer. Okay, and then we're gonna say count plus plus. Right here add dot length, and now let me explain this. So right here this is a coroutine named spawn, okay, responsible for spawning AI instances based on the provided parameters. Okay, so first of all, right here this while loop until the count reaches the desired number of AI instances to spawn. Okay, and inside the loop it generates a random index to select a prefab from the AI prefabs array using the random dot range. Okay, then it instantiates the selected prefab and store a reference to it in the obj game object. Okay, then right in here it selects a random child transform from the current object children and assign its waypoint component to the spawned AI current waypoint property. Then it position the spawned AI at the selected waypoint position. Then after that, after the spawning an AI, it waits for a specific amount of time, which will be giving that time in this timer integer before spawning the next AI instance. And as you know that this yield return new wait for seconds line pauses the coroutine execution for the specific time before continuing with the loop. Okay, and then after that we just simply say count plus plus. Okay, so whenever we spawn a random AI, we're gonna increase this count. And for example, if the AI to spawn is 10 and then this count become 10, then this loop will expire and no more AI character will be spawned. Okay, and this timer is of course for a little bit break between the spawning. Now if you save the script, get back right here, we need to provide the prefabs now. So in the game assets, AI characters, let's start from the first one. So let me actually log this. Okay, add the first prefab, then the second, and make sure that you add the prefab, not the fbx file. Okay, then let's add the third one, then the fourth, the fifth character, then the sixth, and then the seventh character. Okay, and let's just say we want to spawn 10 characters after every 2 seconds. Okay, and that's it. Now before starting the game right here, let's just say start coroutine and let's call this spawn method in there. That's it. Now let's start the game. Okay, so one character is spawn, second, third, fourth, and as you know, after every 2 seconds, the character are being spawned, and as you can see, they are walking in the waypoints. Okay, and when you notice when it reaches 10, they will then stop spawning. Okay, as you can see, they are all walking. Let's check it from the scene view. Here are the characters. As you can see, you can increase this value to 15 and then more character will be spawned, but right now the condition already meet, so that's why it is not spawning anymore. Okay, but if you stop the game, set it to 15, then it will spawn 15 characters. Okay, so our AI spawner script is working perfectly fine, and with this done, let's end this video right here.